Alright, there we go. Yep, as you can see, it is very different this time. You can see me in the background or whatsoever at this point, but yeah. Uh, by the way, just in case, before that, let me check one thing. I just wanna like make sure that thing goes well at this point. So, bloop, and then I'll just go bloop, and I'll just go bloop. There we go. Alright, cool. There we are. Alright, I just want to like test this thing. Boop. Let's see, should jump out at any second now. Ah, yes. Alright, so on my bottom right, there we go, the chat box. So yeah, it's working. Alright, cool, nice. So we have that. So, as you can see, the title of the day today, we are going to make an Enigma machine. However, the title did also say we're going to make Enigma weirder. So first thing first, we need to like understand what is the Enigma machine, or what is Enigma in this case. So let's see if I can like open a few things up. Alright, let's see. Before that, because I remember a while ago, I did come up with a PowerPoint to explain what's going on in this case. So, let's take a look. Where is it? I remember it's during my first semester when I was in like university. Ah, there we go. I have to say, it has to be one of my proudest, um, let's see, presentation I've done. So, let's see. Alright, let's see if I can open this thing up. Let's see if I can even open up PowerPoint at this point. No pun. Okay, so let me take a look. Is PowerPoint opening up? Okay, from the looks of it, it seems like it's a yes. Up there we go, cool. Alright, this means I will need to like change my thing. Okay, it did lag a little bit. Uh... Woo, Lord. Let me quickly change something. I was so close to death. Boop. There we go. Alright, cool. Shoop. Shoop. And then I just go Shift F5. Okay, let's see if I can like switch the stuff. Settings. Oh Lord, it seems like there are no window stuff. Alright, whatever. Let me quickly Alright, before that, let me quickly turn off my coding stuff. And then let's see. Let me quickly add a screen capture in this case. So I'm gonna quickly go through what is an Enigma machine, or the thing to know about, basically. Let's see. Aha, screen capture. There we go. So about that. Use me. Alright, cool. Alright, so now, okay, so this is a slideshow that I've done a while ago. So what you've seen in the background is the Enigma machine. So, yep, I make slides like this or whatsoever. So yep, this is the Enigma machine. So first thing first, and then first thing first, I'm going to cut this down into 6 parts. First part is we're going to talk about who created it and who used it, and then we are going to go through like what it is, and then we're gonna talk about how it's gonna work, and then we're gonna explain what it is so daunting about the Enigma machine, and then the final weakness in order to crack it, and then the way that I'm going to make it worst. And a few months or a few years ago, I made a modified version of the Enigma machine online, so it's available. However, for those who prefer C++ or console-based stuff, this is what we're going to make today. So yeah. So first thing first, we're gonna take a look at who created or who designed the Enigma machine and who used it. So over here, of course, we have Otto Serbius, a German mechanical engineer. In this case, he's the one who designed and created and invented the Enigma machine. However, the original invention for the Enigma machine is for the banks. Like, for example, if the bank want to encrypt a message or save some kind of like secret message in some way, yeah, then they gonna use the Enigma machine. But in this case, the Nazis saw it and then they were like, yo, this thing looks cool. Alright, we're gonna use it. So yeah, we have that. And then second thing, like what it is. So if we just take a look at this big box of thing whatsoever, this is the Enigma machine in this case. So what we have here, it's a lot of stuff. Yep. Alright. Next thing, we're gonna take a look at how does this thing works. So first thing first, oh, okay. About this, I'm just going to explain right away. Like, what is going on is, let's see if I can draw stuff. No, wait, that's my laser pointer. Isha. Let's see. Got my pen. Alright, so there we go. So, most of the time, when we want to like encrypt something, or first thing first, I'm going to explain what is encryption, what is decryption first. So first thing first, encryption. Oh lord, I can't even write that well. So encryption is you turn a plain text, which is like a message, and then you put it through a process along with a key. Like this key can be a word or a number or whatsoever. And then it gives you some messed up gibberish. And then this messed up gibberish is what we call a ciphertext. Wait, can I even spell? Oh no! Oh, oh Lord, give me the eraser. Not chips. Not chips. It's not Tuesday. It's not Tuesday. It's not Chip Tuesday. Let me get my pen back. Ciphertext. Cipher. There we go. So, and then what decryption is doing, it's doing the other way around, turning the ciphertext back into message. But it does not, but not exactly every encryption decryption algorithm uses the same key in order to encrypt or decrypt the stuff. If an algorithm uses the same key in order to encrypt or decrypt the stuff, it is symmetric encryption. If there are different, then it is asymmetric decryption. So let's quickly go through an example. So, for example, one of the most classical encryption is Caesar cipher. So what it does is, let's say we start from A, B, C, D, E, and so on. And then let's say A is 1, B is 2, C is 3, 4, 5, and so on. Oh Lord, I can't even write. And then let's say I want to encrypt Apple, the word Apple. Okay, so I know I'm going to get 1, 16, 16, JKL, that's 12, and then 5. And then I'm going to add a number, let's say 5. So in the end, 1 plus 5, that is 6, 16 plus 5, 21, 21, 12 plus 5, 17, and then 5 plus 5, that's 10. So in the end, I'm going to get F, 21 is U, whoa, no, okay, 17. Oh well, I wasn't expecting that. Interesting. Okay, 10. So in the end, I have encrypted APPLE by using Caesar cipher with a key value of +5, and then in the end I got FUUQJ. So this is the ciphertext. Now, if you just receive this ciphertext and you don't know the key, technically speaking, you do not know what is the original message. So when you send this to your friend, what your friend gonna do is take this ciphertext, convert it into number, and then -5 in order to get the original message. So this is what we call encryption and decryption. So yeah, just to keep just a way to keep a message safe, but depends on the algorithm. Some of them can be broken easily. Some of them needs a lot of time to be broken. So let me erase it. Now, how does Enigma machine encrypt stuff? Basically, it's actually something like, let's do a classical stuff. Let's call hello and then world. Okay? So, what Enigma machine does is every time, so we have A, B, C, D, E, F, and then whatsoever. And then down here we also have A, B, C, D, E, F, and whatsoever. Okay, let's say when we are encrypting the first character, the pairing looks like this. Wait, this should not go here. No. Okay. Oh wait, I should not have done that. That is so wrong. Let's see. Let me get my eraser. Because what's really happening is Enigma machine. Alright. The Enigma machine is actually pairing up 26 letters into 13 pairs. So for example, it pairs up A with E, C with D, B with F, and then other pairings as well. And then for example, let's just say H got paired to, let's say, Q. So during the first encryption, H becomes Q. That's the first stuff. Now, when we encrypt the second letter, does E becomes A? No. No. The pairing changes. The pairing changes. Oh, and of course, we're going to cover like how it changes. And then maybe E becomes B this time, and then the other stuff changes as well. And H previously is paired up with Q previously, but maybe it got paired up with maybe K this time. So E becomes B, and so on and so on and so on. So every time the pairing will change when you encrypt a letter. So let's say on the Enigma machine, you have your like plain text, which is the same letter. Like you just have A and whatsoever. It's just gonna come out gibberish as well because the pairing is different every time. Because A is going to get paired up differently every time for every A you have in your message. Alright, let me erase that thing. So yeah. Alright, now we can move on to the next slide. Alright, so originally the Enigma machine has these parts in this case. So they have the keyboard just to press the input, and then they have the rotors. But what is a rotor? So a rotor is like a big metal plate, and then you can just imagine like they have this like input and output thing, but you can see oh lord, uh-oh. Let me get my eraser on this. Okay, but you can see when it comes into here, you can see there are different wires connected from one side to another side. It's like spaghetti at this point. So it comes in as a letter, like all of these inputs represents a letter, and then all of these little metal studs over here represents another letter. So a letter comes in, another letter comes out, like a signal in this case. And an amazing part is this whole thing turns, and then because this whole thing turns, this means it changes the connection. So if you still remember me talking about every time the pair will change for every letter, because this, like every time when you press a key on the keyboard, it will rotate this rotor. So that's why it changes every time. And then if you have a family car, back in the days, there's an odometer at the front that just like counts out how many miles that you have gone. There are 3 rotors, 1, 2, 3. So every time the right hand side rotor is going to get kicked one place. Now, when it does a full rotation, it's going to kick the next rotor 1 unit. And when this rotor does a full rotation again, it's going to kick this next one as another it will kick this one place. So it's like an odometer in this case. So you can see every time when we press a single key or an input, it's just going to like change up the pairings and all that stuff. Alright, next thing is the reflector. What the reflector does, it's just like, it's almost something like the rotor, but the rotor takes the input or output from the left hand side and then pass the output to the right hand side. However, the reflector takes and returns values on the same side, and I would say this is actually the flaw of the Enigma machine. So we'll take a look at that afterwards. And then of course the lamp board, just to show the output of it. So afterwards, when the Nazi saw it, and then they were like, all right, we're gonna make it worse. And guess what? They just add another plug board. So what does the plug board does is you are going to like pair up 10 pairs in the 26 letters, such that when the signal goes through the plug board, it's going to swap if the letters are getting paired up in some way. So don't worry, we are going to go through an example really quickly in this case. So let's see. So yep, these are all the parts that we have: a keyboard, plug board, rotors, reflectors, and lamp board. So if we were to see them on the real thing, we can see the keyboard is right here at the front, like a typing machine, or what was it called again? Typewriter. Yes, typewriter. And then the next stuff, we have our plug board at the front. So over here you can see there are different letters and there are 10 plugs over here. And then of course these are the rotors. So yep, as you can see, they do spin. And then we have the reflector down over here. And then we have the lamp board right at the front up here. So yeah, those are the parts. Now we're just going to go through an example how to encrypt or decrypt something. So let's say for example I press the letter A on the keyboard. Now it goes to the plug board and maybe A is connected to something, let's say P. So A turns into P. Now it goes to the first rotor, got turned into something, go to the second rotor, turns into something, go to the third rotor, and it turns into something, and then it goes to the reflector. Now here's the thing. This something will guaranteed not connect to itself. So this has to become something else, let's say P again. And then so it sends it back to the original, to the third rotor, turns into something, send it back to the second rotor, turns it into something, turn to the first rotor, turn it into something, got sent to the plug board, but maybe on the plug board T is not connected to anything. So the plug board says, alright, I'm gonna just give you back what you have. And then on the lamp board, T shows up. So we have turned A into T. So this is the whole circuit thing. Like, how does it looks like? Like as you can see, these rotors are actually just like interconnected wires. And then you can see this reflector is actually all 26 studs paired up into 13 pairs. So yeah. And then you can see over here, down here, these switches are the keyboard, and then these lamps up here are the lamp board in this case. So yeah, this is the internal structure of an Enigma machine, but simplified to just 4 letters. But of course we have 26 letters to deal with But yeah, so we have those. Alright, now the problem. So, like, when the Nazis came up with this back in the days, the British was like, oh hell no, how are we going to solve this? So, here's the problem. Now, there are, okay, so on the Nazi sides, there are 5 types of rotors named in Roman numerals 1, 2, 3, 4, 5. So there are like 5 times 4 times 3, which is 60 ways to pick 3 rotors from 5 of them and then put it in a row. In this case, order does matter, so it's actually permutation instead of combinations in this case. So it's actually 5p3, so 5 and then times 4 and then times 3. That gives us 60. And then every rotor has 26 starting positions, and of course it has like 26 ring settings. Now what's a ring setting is something like, if you still remember the rotor structure, like they have this like inside spaghetti thing, there are 26 rotation position for the spaghetti inside. So that's what we call the ring settings. So 26 starting positions, 26 ring settings. And the same goes for the others. Now, for the plug board, there are this many ways to pair up 26 letters into 10 pairs. And just to show you how big this number is, yep, this is how much that the plug board can be paired up. But just in case, there's actually more. It's not just this, just look at this number. Look at this number. Or if I'm correct, that's not just the plug board, it's everything multiplied together. And then this, like the way you set up the initial state of the Enigma machine is the encryption or decryption key in order to encrypt or decrypt a message. So meaning there are these amounts of possible keys that you can set up an Enigma machine and then try to send a message or hide a message in this case. So to put this thing into perspective, a normal human has this amount of cells, and then this amount of humans, yep. Now, a single US has this much of population. So this means for every, and then if we take the whole population multiplied by 226, and then take those citizens and then count how many cells they have, every cell can be considered as an Enigma setting. So that's how much it is. It's extremely hard to crack at this point if you want to brute force it. Now, what I meant brute force is actually something like try every key you can have and then see if you're lucky enough to stumble upon the correct key and then broke the code. Now, there is one weakness though. So if we take a look at this circuit board thing, this circuit structure thing. Okay, first thing first, let me hydrate a little bit. Oh lord. Excuse me. Okay. Okay, so if we take a look at this thing closely, we know that if you take a look at this, we know that when letter Q is being pressed downwards, the switch will disconnect the bulb, and then the rest are ready to light up. So we know that when Q is being pressed down, it is impossible for Q to light up. So with this set, we can know that Q can never be encrypted as Q. W can never be encrypted as W. So generally speaking, a letter can never be encrypted as itself. So this is a flaw. This is a clue. Alright. So this is an important stuff. Yep. Now, so if we were to like think, alright, what they will send? Like during Second World War? What will those Germans send? Well, in this case, like every morning, what they will send is a weather report. So, weather report translated into German, Wetterbericht. Now we have that. So here's how we're going to break the thing. So assume that we have this like gibberish ciphertext that we just eavesdropped from the radio waves. Okay? Now we're going to guess, alright, does Wetterbericht fits over here? But we know a letter can never become itself. So we can see over here T becomes T, and then we know, it does not fit here. Alright, what about here? As you can see, R becomes R, so it does not fit over here as well. So you just try and see where does it fit. Until at some point you see like, okay, everything got converted into something else, as you can see. So I'm gonna guess, okay, maybe this is a phrase, Wetterbericht, over here in this case. Alright. So over here, now we can start guessing the plugboard. Now I'm going to guess that F is connected to X on the plugboard, and then the rotor thing, and then because the rotor is actually like they know the wirings and all that stuff, so they can just immediately apply a current and immediately know what happens next. So X got converted into L, let's say, and then because now we know in the end F becomes W, so we know L must be connected to W. Now you can like just keep on doing this and then try to guess some of the plugboard's settings until you come across with something that contradicts itself. Like for example, over here you've deduced that E is connected to H, but the problem is N connected to E already. E is already paired up with N, but in the end you also say E also paired up with H. So you know at this point they're wrong. And then Alan Turing, which is also a mathematician as well, said, alright, you don't need to check the rest of these are also wrong as well. So you can just throw all of them away. So, now as you can see, like if all connections are wrong, then the rotor position is wrong. So you have to go to the next rotor position just to see what, like, just to go through and see what are like the correct cable connection or pairing in this case. But of course, we immediately think of there are those amounts of rotor positions and there are 5 types of rotors. You're going to have a hard time brute forcing those stuff. And this is why Alan Turing came up with the bomber machine. So what the bomber machine is invented to do is to crack and brute force the Enigma settings in this case by using electric current in this case. So yeah. And of course, we can also use language statistics as well. So what language statistics is something like, for different languages, if you just count up the letters, every letter is going to show up differently. Like, for example, how many A I can find in an English sentence, how many E I can find in an English sentence, how many Z, J, K I can find in an English sentence. And it's going to be different for every language, and it's going to be helpful in this case. So what you can do is you have all different Enigma settings, and then you just put through the ciphertext and then see, okay, which outputs has the best outcome. And when I say outcome, it's something like which is closer to the language statistics result in this case. So let's say, for example, this one over here has the best outcome, and just like an AI, you can just like manipulate and start from there, and every time you do so, it's going to be like a few steps closer to the correct message. And give it a few times, you should be able to figure it out what is the correct settings. And of course, it is my turn to go crazy. And then I'm going to make it worse. So, if you still remember the flaw, which is a letter can never be encrypted itself, so in order to make it weirder or more crazier, I'm going to make a letter able to be encrypted as itself. So the way I'm going to do it is to remove the reflector. That's the first thing. And then I'm going to move the lamp board to the other side. So now we have a perfect flow from left hand side to right hand side. And then I'm going to add another plug board, and then I am going to add another rotor to it. So yeah, over here we can just see you press a letter and then it goes through all a jumble of stuff. It can become something else, or it can become itself, because it's not pairing up 13 pairs from 26 letters. What we are doing here is we are mapping from 26 letters to another set of 26 letters. But in this case, what I'm going to do, like, instead of 26 keys, I'm going for 64 keys because it's the power of 2. Well, of course, prime number is actually favored in cryptography, but let's see what we can do with 64. So, quick demo. And of course, we have this like QR code whatsoever. So yeah, that's the Enigma machine. Now, okay, so if you go to our team's website, you can actually take a look at the Enigma machine online, available for everyone to use. So yeah, okay, I'm gonna hit save it with this. Alright, let me change it back. Boop. Alright, back to little me on the screen. So, let's see. Okay, by the time PowerPoint is saving the changes I've made, I'm going to set up my coding environment. Like so. So as you can see, I have a C++ thing going on. Ready? So yeah, now we can just like set up the stuff. Now, as you can see, I have a self-made library, for functions, CPP, package 2024. So that is a self-made C++ library with all the functions that I might use in the future, or I'm just going to make a new function out of nowhere. So let's see. Okay, PowerPoint is still saving at this point. Okay, there we go. Alright, so first thing first, how we are going to make the rotors and those different parts. or at this point, let's try to make a class in this case. Oh, oh Lord, I'm lagging a little bit. Okay, is PPT done? PPT done? Yep, it's done. Alright, cool. So, first thing first, I am going to come up with a class. I'm going to call it, like, because from the standpoint of function, a rotor or a plugboard can act as a function, and then a rotor spins and then a plugboard stays. Okay, you know what? I'm going to okay, I'm going to add a new file. I'm okay. 64KE, and then I'm going to call it rotor.h. So that's going to make a class in this case. But of course, I'm going to copy some of the stuff. So, bloop, just copy this whole thing, Control C. Okay, just in case. Oh, we need pragma ones up there. Okay. Pragma ones. Paste everything over here. Alright, cool. So what pragma ones does is something like during compilation time, we cannot guarantee which one gonna get compiled first. So we're just going to tell the compiler, alright, just include all of these libraries just once. You don't need to like deal with them multiple times. Alright, so first thing first, gonna make the class. So class, okay, 64KE rotor. I don't know if I'm naming the class correctly. Am I naming? Okay, am I typing it correctly? Okay, let me quickly check how can I like define a class, because alright, just in case I have to be honest, I do not exactly like memorize the syntax, but I memorize or understand the concept of stuff. Because, you know, syntax after all can be searched up and documented and changed. Alright. How to define a class. There we go. Oh, so far I am correct? And then I just go public. And then I just go wait a second. Oh wait, I cannot name it like that. Okay. How should I name it? Fine. You know me. Oval 64 key. That will do it. I'm going to rename this. Come on. Rename. Rename to oval. Boop. There we go. So now we have that. Now, first thing first. We are going to need a vector. What we're going to have is a vector of strings at this point. No, not exactly a vector of string, because after all, a rotor is just like turning a number into another number, because, you know, pairing things up. And then we can just do the characterization on the lampboard and keyboard side. Alright, it's going to be a vector of int. Okay, I'm going to call it left side. And then another of them, another int, and then I'll call it right side. So, oval 64 KE, rotor. So every time when this thing got started up, or like when we make a rotor object out of nowhere, what's going to happen is, oh lord, oh boy, we do need to come up with some presets to, like, you know, set up the interconnection connection of the rotor. Alright, one thing for sure. For int I smaller than, let's go 64. Or maybe I can say int character quantity equals 64. We can change that up afterwards. Character quantity. Oh, I forgot that. User character quantity. There we go. So character quantity, user character quantity, and then for every of that, let's say for now it's 64 or whatsoever, I++, do the following. So what I'm gonna do is left side push back I in this case, like easy peasy in this case. R side dot push back. In this case, this is like an identity rotor. Like, it does nothing. It converts every letter back to itself. So yeah, we have that. So now we can do okay, before that, let me quickly save this thing. Now we go back here. A while ago, I have done a little bit of like testing. So just to show you what's going on. So over here we have a vector list of integers. So we're just gonna take a look what is like the first element. In this case we know is 1. Now, in the self-made library, I have what I call a cycle belt, meaning take a look at the vector, which is this one. Take 3 elements, 1, 2, 3, and then put it onto the right. So these 3 things are going to put it on the right hand side. And at this point, 4 over here becomes the first element in this case. So if we were to like run the code, it will first print out 1 and then it will print out 4. So if we take a look at this thing, okay, this may take a while. Oh lord. How long will this take to like react? There we go. Now as you can see, it's like quite laggy. Okay, let me hit close on that thing. Oh my lord, it's really laggy. Alright. Somehow my machine is like broken. Okay, how long does it take for it to compile? It's just a simple code, come on. Alright, let me take a look. What else? Okay, whatever. Oh, there we go. Okay, finally done compiling. So, if we run the thing, see, over here, it just says 1 and 4. So yeah, we have that, just like what we said originally is 1. Take 3 of them to the right hand side, and then, yep, we ended up with 4 as the first one. Alright, so we have that. So, with that in mind, what we can say is, okay, we can also say, int kick point. For that, it happens. It should be 63. Like when to kick the next rotor. So also we will say kick point is actually character quantity minus 1. This point. So we have that. Let me minimize that. Okay, cool. So we have that. Now, now, in 64 key Enigma, if you've been to the website, then we know we can crank the rotor forward or backwards. Like, unlike the original Enigma machine, the original Enigma machine only gets to rotate in one direction only. But this one gets to rotate in 2 directions. So, let's see. Okay. For this one, it's going to return something. Rotate. Okay, I'm going to say rotate up or rotate down. So, rotate. Okay, I'm going to say rotate up. Take in the number. Maybe the amount of do it. So, amount. So, since we know how to do belt cycle in this case, so in this case, L side is going to be forward function vector cycle belt. Left side char direction. Okay, so moving down is actually R. That's what we've been doing. And then we can say amount. And then our side, it's also the same thing. Cycle belt. Right side. Also our amount. So we have that. Now, we know the left side. Okay, so left side is going to be like ordered number list, and then right side is going to be jumbled up mess. So yep. Oh wait, actually, since integer can be like negative number, wait. Okay, does the cycle belt accept? Oh, wait. Oh, wait. Oh, hmm. Hmm. Safe step. Huh. Because I was like originally thinking if we allow negative numbers to represent the other way to rotate it, I cannot guarantee that vector cycle belt will take in negative numbers. So you know what? I'm gonna do this. Okay, and then we are going to check. Um. Oh wait, I think. You know what? Okay, let me try this. If amount is less than 0, meaning negative, then yeah, we can do the same stuff. However, do it left. Now, else if amount is bigger than 0, then it's normal rotation. Oh wait, I just want to like make sure that cout vector list dot size. Just want to make sure that it maintains everything, or yep. Alright, compile. So at this point, I'm going to predict it's going to print out 1, 4, and 8. There we go. Cool. So it prints out everything. So, yep. Okay, let's just say it's going to also return an integer as well. So we are going to return what position we are at. Oh wait, no. So it's going to return nothing in this case. Let's say a void in this case. Remove by index? No, that's not what I asked for. I said void. Oh, come on, what the hell? There we go. Void. There we go. Alright, and then this time, P. Position. Get position. And then this time it has no input, so it's just gonna like return left side. Wait, how long it's been like Neon City? It should change, like the scenery behind me should change at this point. Let me check. Oh lord, did I lag again? Yep, chances are yes. Ah, crap. Yep, this is what happens when you only have a potato laptop. Alright, by the time it's loading on VRChat, I'm going back to here. So, outside 0, and then yep, it's just going to be that. Another thing is set position. I'm just going to call it target. Oh, okay. Okay, let me take a good look. Hmm. P-value. P-value got stuck. Huh. Is that what I meant by master change in this case? Let me rejoin this instance. Oh lord. Yep, that's a little bit laggy. Hmm. Alright, let me rejoin. Oh boy. Alright, there we go. Now, yep, this may take a while for it to like reload or rejoin the whole stuff. Excuse me. Oh boy. Well, by the time we're waiting for VR chat to come back to life, let's take a look at this. So, set the position. Like, sometimes we want to, like, reset it to 0. So, uh, hmm. Uh, hmm. Let's see. Hmm. I'm going to pull out pencil and paper in this case because I cannot do stuff inside my brain. I have to write it down and see it. 0, 1, 2, 3, 4, 5. Let's say I want to become position 3. Hmm. Okay. First thing first, we know if um if the target is bigger or equal than characters quantity, then we know. Okay. Up. We are no responding. Classic. Classic. Okay. Let's see. Hmm. Let's call it amount again. For now, we don't know. Now, if this thing, then amount is target mod character quantity, else okay, before that, while okay, I'm going to do this. I'm going to let amount become target first. Or, okay, I'm going to say user target. and then say this as target. Let's say it's user target, and then I'm going to say while target is lesser than 0, I'm going to say target is going to be target plus character quantity until when it's not lesser than 0. Now, if it's too big, let's say while target is too big or equal to character quantity, then target is target minus character quantity. There we go. So that will clamp the target as the right thing. So the target will be something like between 0 and 63 in this case, because we're soon we will specify it's 64 in this case. Cannot join instance. Classic. Let's retry. And my cursor is gone. Come on. There we go. Okay. So int, I'm going to call it cur. For now it's 0. Now, while left side cur is not what the target and cur plus plus. And okay, very classic. That's so VR chat. Okay, let's see. Getting back over here. Okay. And also cur is less than character quantity cur plus plus. If it goes outside, okay, so it will break. So if cur is lesser than character quantity, then found it, else out of bounds. We'll just simply return, well, that position. So now it will just return -1. If we found it, and now cur will have the position of the target. And that's the amount we need to move. So left, and actually at this point we can reuse rotate over here. So rotate cur amount. Otherwise do nothing. And we're back to VR chat? I hope so. Let's see. Alright, pretty cool. We know last time it got stuck at 148 or something or whatsoever. Alright. Let's see, where will we go this time? Let's see. Let's go to tools, personal mirror. There we have it. However, I'm thinking in order to make it more optimized, let's see if I can change some of the things. Don't want to see UI. Environment. Perfect. So this means that we can just... There we go. Cool. Well, with this thing gone, okay, this is actually more optimized. Hooray! So yep, as you can see, this is Relativity Express. Well, just done updating it today, so yeah. Can we like make it not pickupable? Oh boy. Oh wait, we still have that UI. Okay, that's a good try. Border. Opacity, face mirror. Mirror grabbable. Ah, there we go. So that's... And then we can just say No borders. There we go. That's more like it. Hey. Okay. Cool. All right. Back to VS Code. All right. So. Okay, we are going to test this, but before testing it, we also need to come up with a debugger in this case. So, in this case, we're just gonna call void. Okay, in this case, it will return a string, and then we will call it print content. So it will return a string with all the contents inside. So one thing we can also do is string, and then we call it router name. For now, it's going to be nothing. And then user router name. Alright, let's have that. So at this point, we can just start giving the router its name. So router name is user router name. There we go. Over here we can have let's call it string, and let's call it answer. For now, it's an empty string. So answer will become router name plus concatenate new line left side something, and then new line, and then right side something. Now the problem is we have to like figure it out what these somethings are. Let's see. Okay, in this case, I'm going to use a comma to separate them. Okay, string, I'm gonna call this answer left. For now, it's that. And then call another string. Or make another string. Call it answer right. For now, it's this. Now, can a string pop back? Oh, yes, we can. Okay, cool. So Okay. For int I starting from 0, I smaller than left side dot size I plus plus answer L is equal to answer L plus L side 1 or whatsoever it is, and then we say to string. Like, will this work? Or how can I convert? Alright, let's take a look at ChatGPT. How to convert an integer to its string representation. To underscore string, huh? Okay. To underscore string. Left side. Oh, cool. We're now at platform 40. Okay. So, first thing first. Answer is this. And then plus a space, comma, space. And then whatever it is. Yeah, whatever. And then we can do the same thing for, oh lord, right, there we go. So right, right, there we go. So now basically we can just like return this thing. So let's get that thing and just remove that. Paste it down here, and then we'll just say return. Boom. So we have rotor name, new line, this thing, and then this thing should be answer L. And then on the next one, it should be answer right. Or maybe let's not use comma, let's just use a space. Yeah, a double space should be good. Alright, cool. So we have that. Now I think we're ready to go. So we have tested it. We've tested. Should be fine. Now let's just include our self-made rotor. So go to dot H. Oh, it should be OWAR. Alright, so let's make a rotor out of nowhere. Let's call it rotor 0. Oh So 64KE rotor. Alright. And then... Oh, I almost forgot. We should call it 64 and give it a name. Let's call it rotor 1. So what I'm gonna do is just print out the content. So okay, so I'm gonna just call this. Okay, that looks scary. Rotor 1. Alright, so I'm gonna just print the content of it. So it will return as a string. So hopefully it's just going to print out from 0 to 63 or whatsoever. There we go. There we go, from 0 until 63. There we go, perfect. Okay, so now, let's clear the console first. There we go, better. So now, that is before rotation. Rotor 1 dot rotate. I want to rotate 3 times. And then print it out again. And then if I do it -3 times, it should print out the same thing as before. There we go. Oh, by the way, if we take a look at the scenery outside, we're now at Getherian number 7. Alright, anyway, let's just run this thing. So, originally we have this. That looks pretty normal. We have that, we have that. Alright, seems pretty good. Yep, everything looks pretty normal. And it's working how it should be. Alright, cool. So now we can make a rotor rotate or whatsoever. Now... Oh lord. Now the problem is... How do you, take a string... and then you split it up? Like, comma separated. Huh. I know in C# or JavaScript there is a way to do that. Okay, let me first collapse that. So I don't have to like keep on scrolling up and down or whatsoever. There we go. For now, this thing will become void. Now we can say set right side string I'm going to call it blob. Like, what kind of name is that? But yeah, whatever. Blob is going to be a comma separated list. Alright. First thing first, let's see if blob has like any stuff. Append, assign, at, back. No. Begin, C string, capacity, C begin, C end, clear, compare, copy, CR begin, and data empty, end, erase, find, insert length, and pause, operator. Huh. Pushback, R begin, R and replace, reserve, resize, R find, size. Huh. Seems like there is no way to do that. Alright, time to build a state machine or some kind? Hmm. Hmm. Alright, let's see. Because if I remember correctly... Okay, let's take a look at the string part I have made. But before that... Yep, let me shrink it down. Like, there's way too many stuff over here. Bools and logics. Strings and char. Char type to string, print ASCII to upper to lower. Force case, find character position. Oh, that might become handy. The position is character or not. String trim might become handy as well. I might be able to use that. It's naughty empty. Like for this one, it's just gonna look for like, is it like completely empty, or it's just gonna like search. If we have like any space or new line or tab, it's just gonna say true or false. So first thing first, for string naughty empty blob. There we go. If this thing oh, alright, that's an event, but I'm not going to spoil it, so I'll leave the rest for you to all, you know, discover and all that stuff. Alright, let's see. String is naughty empty. If yes, alright, we're just gonna see out and then just say KE 64 KE rotor name set right side. This contains white space, will not proceed. Else okay. So assume that we have a comma separated list. Let's say okay. Okay, let's do string plate blob first. And then let's see. Okay, I'm going to do this separate car or separate character. So wait, I can actually make this into a function. Alright, let me try this. To separate string. Oh. Okay. Separate by character. Blob car is separate car or char or whatsoever. So first thing first, string plate is blob. Now int we call it subpurpose will be find character position. First is the string, so plate and then the target is the separate char, and then direction is from the left hand side. Oh wait, I forgot. If is not the empty blob, we will return an empty array. No, not an empty array, an empty vector. Else, do the following. Or maybe I should say vector string answer. And then I can say answer is that thing. And I can say return answer. Otherwise, get the position of the separate character oh wait. Okay, let me have string box. For now, it's going to be that. So in this case, turns out we don't need that, I would say. So while plate dot length is bigger than 0, then do the following. So if plate at 0 is not separate car, then box will become box plus plate dot at 0, meaning take the first character appended to box, and then plate will become we will need to like trim it. So take the string starting at 1 and then ends at plate length -1. So imagine for now the string has only like one character. So character starts at 0. Ah. plate dot length is bigger than 1, and do the following. Else if plate length is equal to 1, then plate will just simply become that. So box will get the first character from plate, and then plate will lose the very first character. So every time it does that. Otherwise, if it equals, otherwise, we're just gonna like straight chop it off. There we go. And every time it gets a separation character, first thing first, we need to say answer dot pushback box, and of course box will become an empty string, and then remove the separation character from the plate. Well, from the looks of this looks pretty fine. So because we are using this, then maybe this means we don't need to like check for naughty empty. So maybe we don't need that. We just need this. There we go. So make a little note. Separate the string into elements in a vector. Separate that by the given character. Okay, good to know. Now we just need to like test if this thing is gonna work. And then when while is done, okay, so if box dot length, meaning if there are some stuff in the box, then answer dot pushback box. Otherwise, don't even care. So in this case, alright, so over here, I'm just going to comment it out just to deactivate this segment of code. Now I'm just going to say give me for string separate, or what does this thing call again? Okay. There we go. First thing first, it's going to be the blob. For now, I'm gonna just type it in directly. Character separated by a comma. Now, this whole thing is going to give us a vector, and then I say, I ask for the element number 3. Alrighty then. Let's see how it goes. There we go, cool. However, let's see if we can get number 8 out of here. Oh wait, I forgot to save. Okay, let's compile that again. There we go, cool. But what if I sneak in that thing in? Hopefully it will like return something like empty stuff. So number 8, that should be number 9. It should return me an empty string. There we go, perfect. So it does returns the entire vector as separated stuff. So back to the original problem is now we just want, now the problem becomes, now we have a vector of strings. Okay, first thing first, oops. Okay, let me have a vector string. I'm going to call it right side list. Is going to be separated by character blob. This will be a list, and each of them are going to contain a string. So it's a string of vector. And then separate the character. Boop. Or wait. Okay. Separate car. There we go. So this will give us yep, a list of integers, but as a string. Yep, so we have that. Now I just need to, if I remember correctly, like, do we have stoi? Let me check. How to turn a string into an integer. Ah, stoi. So we have that. So what we can do is oh wait, first we need to like check. Turn given string from user into a vector of strings. Now, check if size of vector is the same as character quantity. So, if let's see, r side list dot size is not equal to character size, character quantity, then we need to say this whole same thing again. Set r side given list does not match with character quantity. Received quantity is, and then we can say r side list dot size. There we go. Otherwise, if everything goes fine, now, okay, now let's see. Vector int. Let's call it answer for now. It's going to be an empty vector. And then, okay, let's see. For int I start from 0. Whoops. and then I smaller than, okay, r side list dot size I plus plus. So for every list, we will just try to turn it into an int and then push it into answer. So r side list I, this is going to give us a string. And then from ChatGPT, what we have is stoi. So we just have that. So it's from a string to an integer. And then this will give us an integer. So we will say answer dot pushback. There we go. So we have that. That should be good. And then we can say r side will become answer. We go. Cool. Error. What error it is? Is it? Well, guess I have to do this. Turns out cout does not exactly like to take a look at plus sign. Oh wait, when there is cout, they interpret plus sign as arithmetic plus instead of string concatenation. Alright. Good thing. We need to keep that in mind. So yeah. Alright, so let's get back here. So in this case, we have this. Alright, we can remove that. Now, for now, let's focus on... Okay, let's say for now we have only 8 characters. So we have that. Okay. Afterwards, we can say rotor1 dot set r side string blob. Okay, I'ma just say 8765432 also including 0. So from 7 back to 0, separation character is that. There we go. Now we just need to like take a look at the content of it. Alright, let's take a look at this. Compile. By the way, if we take a look at the background, we are now at Azer 0. Alright, run. And there we go. Perfect, just exactly what we wanted. However, if I'm going to be extremely naughty, I can just this may take a while. Boop. Up there we go. Yep, perfect. So it does caught it, which is pretty good. Okay, so now we can set the right hand side of the rotor, and now of course we can rotate the rotor as well. Now we just need to figure it out. Okay, let's see if we can return a bool. So, let's see. Because I was like thinking, when we're rotating, it might rotate the other rotors. So we need to like say, if we do need to kick another rotor, then we will return true. Otherwise, nothing happens, then we will return false. So let's make a note. Rotate the rotor if it will kick another rotor because of the kick point, then return true, else false. There we go. So if oh Lord. Okay. Need to kick. For now it's false. If left side of 0 is equal to kick point, then need to kick is true. Otherwise it's false. And then we will just return need to kick. Okay. Now we can also set the kick point. In this case, we just need to say integer target kick point is target. Simple as that. Alright. Now here comes the important function or method of this class, which is to pass a signal from the left hand side, and then hopefully on the right hand side it comes out as something. So what we will do is it will return an integer, and then let's see, signal left to right. and it gives an input. So step 1 would be something like find the position of it. So okay, so int cur, for now it's 0, and then while left side of cur, wait a second, let me take a look. Okay, input is going to be input modulation character size, character quantity, just to be safe. So while left side cur is not equal to the requested input, cur plus plus. Also, let's just say if it does not find it. So let's just say if cur is still lesser than character quantity, then cur plus plus. So when it breaks, either it found it or it does not found it. So if cur is lesser than character quantity, then do something else. Okay, found it, out of bounds. Oh, there we go. So so now cur, meaning we find the correct coordinate of it. So we will just simply return right side cur. Otherwise, return -1. Okay. Now we just want to like see if this will work at this point. So okay, back to this thing. So let's see. Okay, I'm going to say we are going to have 16 characters. We don't need to test rotation because we know it works. Oh wait, we haven't tested set position yet. Okay, so set position. I want 6 to be there. And then rotor 1, signal from left to right. I'm going to try 4. And then do the same thing as well. 5, 6. Oh, wait a second. Am I doing it correctly? Let me take a look. Okay, I might not doing this correctly. Uh... Okay, I think I might not doing this correctly. Hmm. Oh wait. Okay, the given input is a coordinate, not a label. Because what is on the L side and R side, those are actually labels, not the coordinate. So, okay, L side, we need to get input. Wait, can we even do this? Okay, let's call this thing input safe. Input safe. This will give us the integer label. Now we just need to like find the label. So, int cur 0 while r side of cur is not label, then cur plus plus. Or let's just say cur is lesser than character count or quantity. So when it breaks, either it founds it or not. So if cur is lesser than character quantity, then do something, meaning found it, else out of bounds. So return -1. Otherwise, it will return, let's see. It will return the position of it. So in this case, it's cur. Okay. So set that thing. rotate that. Print again. Do the same thing. Set the position. Rotate. Give us the value. There we go. 0, 1, 2, 3, 4, 5, 6, 7. And then we have 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So, print the content, set it to number 6, signal those stuff, rotate it again, print it, signals those stuff. Okay, let's see. Alright. Oh. Yep. Well, let me do this. Int answer. For now, it's -1. Answer is that stuff. Answer is this. Return answer. So if we get back here, 1 to 1. Okay, let's take a look. What is that? Set position. Huh. Otherwise, it should return fine, then it should return 0. Okay. Whatever. Alright, so if we take a look at that, then we can like check immediately. So at this point we have all stuff, and we try to send a signal for 5 and 6. So 4. So 4, this is actually position 4, but these are actually all labels. There are not positions, there are labels. So 0, 1, 2, 3, 4. Look for number 4. And then we know number 4 is over here, so returns 0, 1, 2, 3, 4, 5, 6, 7, 8. It should return number 8. That's odd. Oh, set position 6. I forgot. Yep, I forgot that. Yep. So now we have that. There we go. Okay. So now we have this thing. Looks of it looks correct. So 0, this is position 0 over here. Position 1, position 2, 3, and 4. That is label number 10. Label number 10 is over here. Last one 15. Okay? 5 is label 11, which is position 0, position 1. So give us 1. And then 6, 0, 1, 2, 3, 4, 5, 6 is label 12. Label 12 is right here. So 0, 1, 2, 3. Give us number 3. Now, rotate 3. So starting from 9 back to 8. So from 9 back to 8. And then from 12, and then we have 5, 13, 6, 12, 5, 13, 6 down over here until we have 3, 11, 4. So 3, 11, 4 right there. Perfect. So yeah, at least we now know signal is working. Yay. Now we use left to right for encryption. And we're going to use right to left as decryption. Because just like the method I mentioned over there, I only have a one stream direction stuff instead of like wrapping it backwards. That's also one of the flaws in this case. Copy. Paste. Alright, cool. From right to left. Okay, cool. So input, input. Label is now right hand side. Meaning from get the label from the right hand side. And then okay. If the left hand side label is not the same as the label as we're looking for, and also when cur is inbounds, keep on plussing it. For now, answer is 1. Answer is -1. If we do that, an answer out of bounds. Yep, from the looks of it, it looks correct. Alrighty then. So now, let's go back to here. Okay. Signal from right, right, right to left, left, left. If I remember correctly, the first one is 15, and then 1, and then 3. So compile it. . Boop. There we go. So over here, it does says, okay, 456, 0, 1, 2, 3, 4 over here, and then 5 over here, and then 6 over here. Now over here, I know it's 11 and 1 and 3, so send them back should give me back 4, 5, and 6. So there we go, it's working. Yay! So now a router can encrypt and decrypt stuff. And then basically, okay. Now since we have the router ready, now we just need to prepare the plug board. So yeah. Alright. Alright, cool. So the router is now ready. So technically speaking, we don't need this at this point. However, what we can do is we'll just duplicate this. Okay, fine. Let me copy and then paste it over here. And then we will rename this as plugboard. And then we just change this plugboard. Oh, with a capital B. Yep, that's one thing. Okay, so definitely need character quantity. Kick point. There is no kick point at this thing. Plugboard name. Okay. Plugboard name. For now, there's nothing at this point. A few stuff that I might let it remain are some of the stuff. Okay, there are no rotate. There is no position. There is no set position. Set side. Well, we can say append pairs or something. Well, one thing about the plugboard over here is something like you can say one is connected to one, but that's redundant. And then you can say I want one to connect it to two. And then now the problem becomes, if 1 is connected to 2, then from the right hand side, if we send a 1, where 1 is going to go? So okay, let me get this thing. Plugboard name. Do we have plugboard name? No, plug. There we go. So basically thinking, one way to like set up the plugboard is by just giving it the right hand side list. And that's it. So technically speaking, we can just like reuse this thing. So if blob is not empty, or that thing is going to become a lot of those stuff, check if size of a vector, if it matches that thing. Okay. Seems like that's good. Alright. Set kick point. There is no kick point. And then signal from left to right. It's the same thing. So if this plugboard, technically speaking, is done, Alright, let's see. Now, let's hit save. Don't want to look at that anymore. Let's go back here. Plugboard P1. Oh yeah, I forget. Include OWASP64 plugboard.h. So that's P1. I'm gonna give them the same name, P1. Now, P1 going to set right hand side to that thing. Now, there is nothing called set position. Oh, print the content. I think maybe we can just like duplicate that thing. So we take a look at rotor. Print the content. Yeah, print the content. Same stuff. Plugboard. Print the content. Paste it over here. Whatever. And then constructor. Alright, let's take a look at this. Control C. First thing first is to change the plugboard name. There we go. Plugboard name. So character quantity is specified in there, and there is no kick point. And then for everything, just push back the same thing, and we're good to go. Print content. Plugboard name. There we go. Alright, so we have that. Save. Going back here. Over here, it's just going to be P. And then P. 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 And P. And P. There we go. So there we go. We have that. Oh wait, we're still at Azer Blue? No. Azer 0? Okay, we'll take a look at that if the scenery outside will change. So. Okay. Oop. So if we take a look at this thing, like 15, 1, 3, 4, 5, 6. Yep, it's working. So yeah, pretty cool. So this is the plug board. So plug board does not spin, rotor spins. Okay, pretty cool. So now, we just need to come up with the keyboard and the lamp board. But technically speaking, the keyboard and the lamp board is actually the same thing. What it does is it takes in a number and then it converts it into a character. So, huh. Let's see. Okay. Let me think about this. Let's make a new file. Or, you know what? Let's just copy and paste again. Then just rename it. Keyboard lamp board. Key lamp. You know what? I like that name. Let's go. Class. Key lamp. Alright. I know it's going to have a lot of stuff. So, key side and lamp side. Keyboard vector. Lamp board vector. Now there is no kick point. Now rotor name, key lamp name. We'll call it that. So every time when it gives us that, it's just okay. There we go. Key lamp name. User key lamp name. Oh, just in case, quick note, when the stream is done with this thing, I will upload this thing to on our GitHub. So if you want to download it, go ahead. But if you don't, we will also put a link on our team's website as well. So yeah. User key lamp name. Alright. So in this case, they will get a name. They will get a name. Character quantity is that thing. There is no kick point. Also, set R side. Okay. Let's say set K side. Okay. Key lamp. Key lamp name. Set K side. K site list. So K site list. Key lamp name. Key lamp. So as you can know, this is the keyboard and the lamp board, but combined in just one class. Set K site. K site list. Otherwise, do this and K site list. K site list. This K site. Okay, but K after all is going to be a whole bunch of characters. So in this case, oh, wait a minute. Ah, okay, so in this case is not a vector of int, instead it's a vector of char or car or whatsoever. So good to know. Okay, we'll come back to this later. Let me just type that thing in. print content. Oh, okay. K answer L. So K K that's the K side. Now the L side. Answer L. L side. Answer L. Oh wait, that should be the K side. Okay, and then we can have key lamp name. K side with answer K. L side with answer L. So that's print content. Okay. Well, we'll come back to that. Rotate. There is no rotate. There is no position. There is no set position. There's only set K side. Okay. Key lamp. Okay. Okay. Let's see. Because this holding, okay, fine. I'm going to be strict enough and then just say we are going to get every element. In this case, it's a string. And then for every string, we will get the very first character of it. Oh wait, what? Okay, what is answer? Answer is an int. Okay, here answer should be a char. There we go. So answer go. There we go. Now no kick point signal. Oh. Okay. Okay, we'll come back to that. Now over here, It's the same thing. However, let's call it set L side. So, same thing. Set key length, L side, L side list. So, if L side list is that, then this will be L side list. And then answer of that, L side list, pushback. And then L side, our answer. Okay, so we have that. Now, signal. Okay, K to int. And then our input is a character. So that's very different now. Now, it doesn't has a range. So, int label. Nope, we don't need that. Okay, so for now, current is 0. So while K side of cur is not what we gave, and cur is still inbound, then do that. Otherwise, when it breaks, either it finds it, or it's out of bounds. So if cur finds it, answer is actually cur. Otherwise, return -1 and then give us answer. And then, oh lord. And then I would say, car, okay. So, signal integer to lamp. It's actually easier. So, int input there we go. Hmm. So, input. Basically, it's just actually just return lamp side of input, and that's it. Yep, that should be it. So, basically we have this. Now we can say set K side oh wait. Hmm. Okay. User K site list user L site list user list separator car. There we go. So set K site with a string. String should be user K site list user the separator char set L site user L site list user list separator char. There we go. Oh wait, that should be char. There we go. That's not exactly what I meant. There we go. Alright, now we can test that thing. Before that, let me hit save on this. And let me hit save on that. Now we can say K 16. You know what? Let's go with 26. Let's also include wait, did we still call it router call? No, it's now plugboard. Wait, no. Key lamp. Okay. Keylamp.h. Yep, there we go. Okay, so that's character quantity right there. Key lamp name, let's call it K1. Now, the list 26. Well, you know, A B C D E F G H I J K L M N N O P Q R S T U V W X Y and Z. Now, okay. Separated by comma. Oh wait, no. Now the lamp board. Well, I would say the same thing. And then the separating character, which is a comma. So basically saying we have already set the site. Now, let's give this a try. K1 dot signal K to I. Give it a character, say A. Oval 64 KE. Rotor, let's call it R1. Let's just do it simple for now. Just one rotor. No flugboard, no nothing. Uh-oh. Okay, 26 letters. Rotor name. R1. For now, R1 dot. Okay, I'm going to set the right hand side of it. String blob. For now, it's from 0 to 25. Okay, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and then 24, and 25. Separate character. Alrighty then. So now R1 dot print content. Okay, so A becomes a number. R1 signal from left to right. Int. Okay, let's call it key number. From this to that. So from A becomes a number, and then from a number becomes another number, and then finally K1 oh wait, let me do this. K1 I back to L, R number. In this case, it should not be int, it should be char. Now, C out, K number, go, and then R number, and then L number. One, 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 and one. There we go. Now, do the same thing again. This time from K1, the signal, interesting. Oh. Okay. Let's see. Because the way to like decrypt stuff by using this new version of Enigma machine is by pressing the lamp board. Weird metaphor, but I hope that makes sense. Okay. Alright. Let me do the same stuff. But instead of K, this time is L. So L to I. I meaning integer. So let's see. Int cur. Alright, if L side cur input cur character count, do that, do that, do this, do that. Okay. Done. And then this should be easy. I to K. So it returns the K side. So now K1 signal. Now we are trying to decrypt. So from L back to I. Char. So that is L number 1. This will give us an integer. So this is from lamp board number 2. The second set. Now, rotor 1. Signal from right to left will take in L number 2. And this will give us a number, R number 2 equal that thing. And then finally, from a keyboard, we can know signal from what was it? From integer back to k. And then we need that number from the rotor. Give us the character k number 2, R number 2. There we go. So okay, okay, we just need to like type out keyboard, give us the number, rotor, give us the number, lamp board. Now, same thing over here. Okay, just in case, did VR chat got lagged out again? Alright, let me check. Oh lord. Yep, it's now lagging. Okay, this time it got stuck at 150 instead of 148. So that's actually something pretty odd. Alright, anyway. Alright, cool. Alright, let's get back to this. So, converting back to keyboard. There we go. So the upper part is encryption, and then the lower part is decryption. So, boop. and then I'll just go mo, and then I'll just go mo. There we go. So L number 2. Okay, so from keyboard, we have A becomes K number 1. K number 1 of the rotor becomes R number 1. R number 1 of the lamp board becomes, oh wait, R number 1 of the lamp boards becomes that. So at this point, L number 1 is a char. Let's still use that. Of the lamp board, it becomes L number 2. Okay, L number 2. After L number 2, it becomes R number 2. R number 2 of the keyboard, it goes back to K number 2. Alright, let's just hope that this thing works. This is a single rotor encryption. Encrypting the letter A into something. Not quite sure what it is. Let's take a look. So, keyboard. We pressed A, so A becomes 0. 0 becomes root of 0, A. Oh, A becomes. Oh no. Alright. Let's give this a spin, shall we? So, so R1, rotate. Let's say rotate 8. There we go. Boop. So when we press K, A becomes 0, 0 becomes 16. 0 is right over here. Oh lord. Or is it? It should give us the relative, wait. Oh wait. These are labels. These are coordinates. So when we press A, it needs to find label number 8. Label number 8 is over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is 16? Wait, did I count from 0? Oh wait, okay, so 16. 16 plus 1, 17, and that's Q. Alright, and then Q goes back to lamp board. Give us 16, 16. Go back to rotor. 16. Over here, meaning at number position 16. So that's actually label 8. Label 8 give us position 0. Or coordinate 0. Go back to keyboard. Keyboard does translation. Back to the character. So there we go. A single rotor encryption. Alright. Okay, this is going to be interesting. Boop, boop. Now we're going to have 3 rotors. So this is going to be the classical Enigma machine. So R1 set position. Well, let's try 1. 2 and 3. Over here, let's go for 2 and 8. Like, whatever. That side. Okay, there we go. And then we're gonna go with starting from 25, 24, 23, 22, 21, 20, 11, 10. And then down back to 0. There we go. And then that's for R2. For R3, I would say this is actually one of the beauties of this oval 64 key Enigma thing, because on an ordinary Enigma machine, you just have to stick with the rotor. But in this thing over here, it's both a pain and a beauty at the same time, because you get to set its internal wiring. Okay, let's see. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. There we go. So that will be 3. Okay. Two and 3. There we go. Now let's see. Okay, how am I going to rename this? Because, okay, first it got this. An integer. Another integer. R2. Another integer. And then back to the lamp board. Alright, there we go. Okay. Oh wait, we still need R3 as well. So R3. Okay, there we go. So technically speaking, we have 4 numbers in between. Let's call this N1, N2, N3, and N4. Let's call this C0, and then let's call this C1, meaning character 0 and character 1. So let's go. C0 and C1. Integer, N1, N2, N3, N4. Alrighty then. Now, let's see. First thing first, K1 signal from K to I. So you need to input C0, and that becomes N1. And then R1 signal from left to right, taking N1, like we know R1 is over here, so it takes N1 and then it reproduces N2 in this case. So N2 is that. And then N3 is R2 dot signal left to right from N2. And then N4 is the output of R3. So signal L to R N3. There we go. And then finally C1 is we use the same K1 as well. So K1 signal from I to L N4. There we go. Yep, there we go. It's just a chain of functions, as you can see at this point. So over here we can just see out C0 keyboard N1 and then R2, wait, no, R1 and then N2 and then R2 and then N3, and then R3 goes into that, N4, and then finally N4 L0, which is lamp port C1 and line. There we go. So we have that. Now we're just gonna do the opposite. Okay, there we go. Now we're gonna do the opposite. So from K1 signal, from lamp port back to I, we have C1. Okay, and that will become N4. Now N3 will be R3 taking N4. So signal from right to left, N4. Now N2 will be R2 the signal right to left, N3, and then N1 will be R1 the signal right to left, N2. So finally N1, so C0 is K1 dot signal from I back to K, N1, there we go. In this case, I'm gonna change the direction just to know that this is decryption. All right. Miss any stuff over here? Okay. Now the only thing is okay, let's do this 4 times. So for int of I starting from 0, I is smaller than 4, I plus plus. Do this thing 4 times. And every time when we done doing it, R1 rotate 1. C0 is A. At least now we know that. see out for. So at least now we know that it starts over there. Okay. Compile. Run it. Alright, let's take a look at it. So we set it up. Print 1 to 8. So that's set position along with those stuff. So as you can see, every time when we press A, this time it becomes W, and W goes back to A. That's decryption. And then we rotate the rotor and then press A again. This time A becomes U. And then when U is decrypted, it goes back to A. And so on. And then A become S, A become T. So yeah. So with this, basically, we can finally encrypt stuff and decrypt stuff. Yay! Okay, so the manual encryption and decryption works in this case. Now the only problem is something like for now, alright, yeah, we will stick with 3 rotors, and then you cannot change that. I'm going to go higher. I'm going to let the user able to arrange the module themselves. So they can arrange like any plug board or rotors in between. Now, about the plug board, I forgot to mention. Okay, let's only have. Okay. Let's have 1 plug board. So 64 KE plug board P1. Also 26. Plug board name. Let's call it P1. So for now, P1 dot set our side. There we go. How do we want to connect it? Okay. 0. And then all the way. There we go. And then we'll go with 19, 21, 23, and 25. Okay, let's not have that. There we go. Boop, boop, All right. Hmm. Okay. So now, okay, let's see. P0, R1, R2, R3, N5, and then there we go. So now we have N5. Oh wait, and then before that, 1, 2, 3, go with that. Plot port 0 becomes that, 1, 2, 3, and 6. Oh lord, that's a lot of stuff going on. Hmm. From this to that, and then N2 is going to become P1 dot signal from left to right. From N1, and then from N2 goes to N3, and then from N3 goes to N4, and then from N4 goes to N5, and then N6 is going to be plug board in this case. Wait, did I go for P0 or P1? Oh, P1. Okay, cool. P1 dot that from left to right, N5. Now N6 goes in here. Alright, cool. K0 becomes, okay, C0 becomes N1 under K, which is keyboard, and then plug board, and then R1, and then R2, and then R3, and 5, P0 again, C1. There we go. So we have that. And then we'll see back out again. Alright, so from C1 back to N6, Okay, so N5 is P1 signal from right to left from N6. Now, and then N5 becomes N4, and then N4 becomes N3, and then N3 becomes N2, and then N1 comes from plug board. So P1 the signal from right to left, N2, and then finally N1 converts from integer back to keyboard character. So we have that. And we'll just change it up, the arrows a little bit. Let's see. There we go. Alright, cool. Boop. So we have that. Alright, let's run it. Okay, what does our plug board say? Ah, fair. There we go. So 11 always becomes 18 because of the plug board. But based on rotor 1, yep. 12, 13, 14, 15. Oh, we always rotate rotor number 1. I should have rotate rotor number 3 instead. There we go. Alright, so every time 18 always becomes 12, always becomes 9. But this time 9 becomes 9. Okay, so rotor number 3. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's this. The 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 becomes 9. Okay. And then the next thing happened is this thing got kicked. So the next thing I need to find is 18. 18 is slightly less. Because it got kicked once, so 1, 2, 3, 4, 5, 6, 7, 8. But it got 6, huh? Oh wait, number 6. Okay, so 0, 1, 2, 3, 4, 5, 6. Oh, 15. 15 is right here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh wait, the answer gets even weirder every time. But weird stuff is every time it just turns it back. So, yep. So at least now we know it can encrypt and decrypt stuff, which is actually pretty good. Mm. Hmm. Now, let me think. Because now, like, the modular part is ready. Like, the modular part is ready. Hmm. Hmm. Let me think about this. Like, of course we can go more than 26. 26 is just an arbitrary number. Oh, 年沃尔尼. Just in case, if you take a look at the title we have over here, uh, I'm making Enigma machine, but even worse. Anyway, how's your day been doing, Ernie? Alright, let's see. Um, what's Enigma? Oh, okay, so at the very beginning of the stream, I have explained what is Enigma, but in this case, I can just quickly go through everything again. Uh, let's see. Just in case, Ernie, have you ever heard of cryptography? Just in case. Alright, let's see. Okay, for now, I'm just going to keep on crypting and decrypting stuff. Oh, okay, cool. So you heard of encrypting and decrypting. So okay, cool. So let's see. Are you simulating one of those machines or something? Kind of, but okay, so oh wait. I have a potato laptop, so I cannot like go to Google or something, otherwise it will lag the heck out of this thing. Uh Alright, let's see. How am I going to okay. Before that, let me adjust one thing. There we go. Alright, so how am I going to explain this? Okay, I'm going to do it this way, so um let's see. Okay, I'm going to use hashtag to represent exit. Okay, let me quickly ask ChatGPT how to get a single character from the user. Um, from the user. There we go. Alright, cool. So, let's see. C in variable. Okay, if your PC lagging, why are you in VR chat? Yeah, you know, just in case. I'm trying new stuff. But so far for now, it's fine. But if I open way too many stuff, it starts to lag. Like for now, it's fine. Like you can see, it's me in the background or whatsoever it is. C in variable. Let me take a look. Well, over here, ChatGPT tells me to use C in dot get because I'm planning to do a while loop, like until when I hit a variable. No. Until when I have a character that represents exit, then it will break the loop. TF is dot get. Oh, okay. I'm going to type it out in this case. Let's see. First thing first, I'm going to do char, and I'm just gonna go user insert, and then so I'm gonna just do let's see. How should I? Okay, so cin dot get, but in this case, it's going to become user insert equal that thing. So while user insert is not hashtag. I cannot think of any other characters, so yeah. Oh, it is for characters, so if you insert a space, it doesn't terminate, and C terminates it. Yeah. Yep. Alright, let's see. So now I'm just going to do this crazy stuff again and again. Let's see. Control C, Control V. So every time this equals user insert, and then I'm just going to print this line, like this long line. So copy and paste. And then how should I do this? Looking for via trade stream, I randomly found someone that's also coding. Hey, thanks for the follow. Cool. Um, let's see. Okay, and then when it becomes that, then I will say Control C, and paste it in there. So while user insert is not waffles again, or hashtag waffles. That's the first time I call a hashtag a waffle this time. Control C. Hey. Oh wait, okay, that should not be a string. It should be a char or car or whatsoever. How do I get C++ to run in C++ with headers? It is a total. this question is kind of recursive in a way, so I don't quite get it. Let's see. So this is decryption over here. Okay, I do need rotate for this one. So exit out. Okay, let me quickly do one thing. Let's see. How do I get C++ to run in VS Code with headers? I had a lot of troubles. Oh, about that. Okay, let me do this. One easy thing is I only have header files. I don't have like weird includes, like some of them are header files, some of them are CPP files. That always messed me up. So I was like, fine, if I can include every method and every important stuff in just one nice neat file, then why not? So yeah, we have that. So I'ma just hit save. Like, it's just easy stuff. Like, you just include some of the libraries you need, and Pragma wants it, and include some of the libraries that you self-made, and then you just start define a class with everything public, and then everything's done. That's all. Boop. And then I'll have that, and then back to this. Alright, let's see. Okay, let's see if I can like define a function. So, or at this point, I'm going to call it a routine. Yeah. Talking about actually like downloading outside library and... Well, okay. These libraries over here, they are all included by default when you start using C++ or something. This library over here, I make it myself, so I know what I'm doing. Alright, let's see. And that file over there, like the for functions, like this one over here, it's just a whole bunch of functions that I made. That's all. No class, no nothing, just functions. Yep, it's my own library, so I know what it is. It's like my own little toolbox or something. Was trying to include n curses and it was impossible. N curses? Never heard of that. Just in case, what is that though? Sounds interesting and sounds scary at the same time. Okay, so at this point, I'm gonna call this thing int, and then I'm going to call this rotate. For now, I'm just going to like simply let it rotate just one place, that's all. It's for making terminals pretty and give them more functionality. Alright, like prettiness? Okay, fine, but not the primary good stuff. And then give them more functionality. Okay, should be fine. Like keyboard mouse input inside the terminal and actually being able to use colors. Okay, about the colors thing. There is actually an escape character just to change the color of the printing though. Like come on, we have ChatGPT. You can just like ask ChatGPT like how to print colors on the console or something, and it will just give you something like a backslash and then some escape characters just to print just to switch the colors or something. I remember I did that in the past, but I cannot remember what are the characters now. But if I remember correctly, like 31 somehow means red, and then 32 means different colors. Like they have blue, green, and yellow. But in the end, it's actually just RGB, so yeah. Makes it simple. If you want to center your text, you just up in the X/Y. Huh. Center the text. Like when you say center the text, do you do you mean by like padding the screen? No, padding the string with spaces? Rotor, rotate. Hmm. Neat cake. Neat cake. Okay, I'm going to call it neat cake 2. And then I'm going to call it... Oh lord. Yeah, basically. Yeah, I see. So technically speaking, you can make a function for that. Has a lot of functionality, just don't know too depth since I barely start using it. But just in case, like, why did you like start using like C++ in the first case? Is it because of assignments, or is it because of passion, or something else? R1. Uh, hmm. Okay. Kick the rotors. There we go. Alright, let's see now. So for now, I'm going to say bool. Okay, I'm going to do it something slightly dangerous, but okay. R1 dot rotate. Just one. Okay. And then it's going to return or tell us if it's going to kick the next rotor or not. If so, we will rotate 2. And then if so, R3. No, I did it wrong. It should be starting from 3 first, and then 2, and then 1 dot rotate, like a fast rotor, medium rotor, slow rotor. Learn C. Okay, let me take a look. Oh boy. Curious, I learned learned C before C++. Okay, yeah, fair. So I wanted to learn some more about OOP. Oh, object-oriented programming. Yeah, not bad. That's okay. You're gonna love C sharp, I guess. Public private, since C does not have any of these and most other languages. Oh, okay. So basically, public private is something like public is you allow modules outside the script to access it, but private is something like nope, you can't use this, you can't get this. Yep, that's one of the concepts. But in OOP, like you have many stuff. Like you have inheritance, you have overriding, and all of those good stuff we have. So yeah, okay, rotate 1. Boop. Huh. Control C. Let's see. Boop. Boop. There we go. So, yep, we don't need that thing. Let's remove that. Char user insert. Boop. And boop. Okay, don't need this anymore. Well, as you can see, we have a lot of plug ports and all that stuff. We have a lot of initializations over here. Okay, let's take a look. Set position. For now, the set position over here. Okay. Okay, let's say cout R1 pause. For now, we have that. Boop. R2 pause. There we go. And then boop, boop, boop. R3 pause. And then we're just gonna do cin. Oh wait. Yeah, whatever. Int R1 pause, R2A, R2 pause, and then R3 pause. There we go. So over here, I'ma just do cin, and then R1 pause, and then cin, R2 pause, and then cin, R3 pause. There we go. Alright, now let's do cout, end line, whoops, let me, nope, there we go, encryption, end line, there we go, and then do the same thing, cout, end line, decryption. There we go. Okay, let's just hope that this thing runs at this point. Okay. So far we don't need these. We don't need set positions, but we just need some of the initializations and settings and all that stuff. Okay, let's just hope this thing runs. Wait. What's that? Oh. End line. Nope. We don't need that. There we go. Save. Alrighty then. I just hope that this thing runs. So, boop. Run. Nah, just compile. Now, as you can see, I'm also running Linux on this thing, so yeah. Alright, let's hit clear. Just run. Boop. R1 pause. 16. R2 pause. 8. Finally R3. 4. Whatever. Okay, that's not good. That's not good. Infinite loop. Uh. Ah, I see. Alright, that's why. That's why. Yep, my fault. My fault. The whole thing just blew up. Classic mistake. C0, yes? Wait, is this C0 or C1? Alright, I think I messed up a little bit. Okay, so user insert is cget as user insert is that thing. Ah. Hmm. Okay. Oh wait, I think okay, let me take a look. User insert is c.get again. Alright, let's put it right here. Alright, let's do the same thing. Control C, Control V, and then just user insert c.get, Control C, and then boop, hit save. Alright, recompile. Boop. Okay, cool. Whew. Clear. Just run. Alright. 16, 8, and 4. Alright, encryption. Okay, I did not enter anything. So maybe I need C ignore in this case. Let's take a look. cin dot ignore. There we go. Boop. And then there we go. Alright, 16.8.4. Okay, so Ernie, if you're still here, this is what I'm trying to make in this case. So it's a small mini Enigma machine, but slightly different. So in this case, I'm just going to try to type in hello world or something. So I'm gonna go caps lock H. So huh. Alright, let's see. That was strange. Oh wait. Oh wait. Is it because... Okay, let me try this. Okay, I also need to say... Whoops. Cin dot ignore. And then cin dot ignore. Alright, let's see if this works. Go. Boop. 16.8.4. That's not good. Hmm. But why does it go through? Huh. Okay, debugging time. That's one of the hardest moments. Hmm. Hmm. Let's see. Hmm. I would say these looks fine and correct. Still, a little bit odd. Let's see. Oop. And then let's just go, just run. Okay, so 16, 8, and 4. Encryption. H. Huh. So it does interpret um so it does interpret enter as a character. That's actually pretty odd. So cin dot ignore uh let's see what will happen. Might be bad. Alright, 16, 8, 4. Yep, it's bad. Hmm. Oh Lord. This is actually hard. Hmm. Alright, let's see if I can do it this way. If user insert is not this, then do the following. Alright, let's take a look at this. Tab, there we go. And then boop. Okay, let's take a look at this. Okay, for now, user insert, let's just say it's A. And then every time it will read this. And then if it's a hashtag, it will do nothing, go back to the loop, and then break. Okay, hopefully this works. So if that is the case, then okay, every time post it over here. Wait a second. User insert. Oh, okay. So over here, also gonna assume that it's A as well. So get if user insert is not hashtag, then do the following. Paste it right here. There we go. In this case, we don't need that. Okay, there we go. Insert is not that. Get, and if user insert is that, it's not that, and do the following, and then you go back here. Okay. Hopefully this thing works. Okay, in this case, just clear out everything and just say just run 1684. 1684. Caps lock H. Okay, let's see. cn.get. cn.ignore. sometimes what's blocking us is some of the stupidest stuff that we have. Control C. There we go. And rerun it again. 16.8.4. Encryption caps lock H. There we go. E L L O X as a space WORLD. So we have encrypted hello world into the UDVHVRGESLB. Oh, by the way, I almost forgot. Oh wait, I almost forgot. Control C. Because I forgot to actually set the rotor position of it. Okay, so for that, R1, oops, R1 dot set position is R1 pause. There we go. And then we have 2 and 3. 2 and 3. Now the same thing. Oh lord, laggy. For no reason. Okay, there we go. So it's safe. Alright, let's run this whole thing again. Uh, 16.8.4. And then we're just gonna do the same thing again. Oop. H E L L O X W O R L D. So now we have TEUGINCFRKL. Now hashtag decryption. So let's insert T. Where did X comes from? I said T. That's odd. U G Huh. The last one was L, and then L keeps on. Interesting. Decryption. C0. Ah! That's why. Okay. Save. And then done. Recompile. And then we're just gonna go clear. Alright. And then just run the whole thing again. 16, 8, 4. Alright, caps lock. H, E, L, L, O, X, W, O, R, L, D. So, teogenic frickle. I have no idea how I came up with that, but anyway. Hashtag decryption. So the first thing is T, and it goes back to H. T, E, U, G, I, N, C, F, R, K, L. And we just get H, E, L, L, O, X, W, O, R, L, D. There we go. And that is a successful encryption and decryption over there. So yeah, we have that. Cool. Okay. Now, alright, cool. Now I'm thinking about, instead of like cin.get, I'm thinking about getLine. And then we're just going to just simply get the very first character every time. Yeah, that should be good. That should be fine. So, hmm. Oh Lord, I feel good about this thing. So technically speaking, we can just like every time set up a different plugboard setting whatsoever, and yeah. Okay, let's see. Okay. I'm going to call it string add. So now I'm just going to make a small mini command prompt, something like that. Okay, so string user command. For now, it's an empty string. Okay. while user command is not exit, do the following. If user command, okay, okay, cin dot get line put it into user command. Oh boy, wait a second. Okay, let me ask ChatGPT how to do this. Here we go. Oh wait, we don't have that. Huh. Instead, it should be this. There we go. So every time we do that. So if user command is not exit, and do the following. If user command help, then just print the manual. Else if user command r1 dot set r side and then set r side. Okay. Insert content. Okay. R side list is a string. It's going to be cin. No. Get line from cin r side list. So get line cin into r side list. Insert separation character. Here we'll also have string sepakar, and then of course we will get line, and then cin, and then sepachar or sepachar, and then we will do r1 dot set r side along with the blob, or okay, r side list, and then we have sepa char dot at 0. Okay. If our site list is bigger than 0 and sepachar dot length is bigger than 0, then do the following, which is that thing. So this is set R1 side. Otherwise, you know what? Let me compress this thing into just this. Oh wait, it has to be a new line? Aw, sad. Alright. Well, guess I'll just copy and paste this whole thing. R2. Set R side. And R3. R3. Else if user command R1 dot print yep, we just do R1 dot print content, and then the same thing happens. R2, R3. Same thing over here. R2 and R3. Oop, oop. So set print R1 dot rotate what we can do here is okay, string user input, and then get line, and then let's see. Because I'm thinking about error detection and all that stuff that, user can be naughty sometimes. Oh boy. User input. R1 dot rotate user input. There we go. Paste. There we go. And that. And then this. And then that. And then this. Okay. RA meaning all the rotors. Set pause. And then we actually have set pause at the very beginning. Control C. Paste it in there. And then we just go okay, there we go. I'm also thinking about maybe I'll just add one more rotor just to make it 4. Hmm. Four. There we go. Hmm. Uh. Oh Lord. Hmm. Starting from 25. Oh wait, I have the reversed one. Oh Lord, this is interestingly hard to come up with. But I'll just go oval 64 KE rotor R4. '26. I was thinking about 64. Hmm. '64, '64, '64. Hmm. And then the 64 of that. 64. Um. Keyboard, lampboard. There we go. And then we need another plug board. So yeah, we have that. Alright, let's take a look. Let me pull out my calculator. Alright, cancel. 26 plus 26, that's 52. Plus n numbers, that's 62. And then plus a space. And then plus a full stop. Oh, that will do. Okay, A, B, C, D, E, F, G, H, I, J, K, L. Or, okay. Let me think about this. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then plus, minus, multiply, divide, parentheses. What else? Decimal point. I don't know. Let's take a look. Clear 26 plus 10 numbers, 4 operators, 2 parentheses, and then a full stop. That gives us 43 so far. Okay, how about... Okay, I need a space bar. And then I need... Oh, Lord. Okay, let's see if I can use a space as a separate character. It should be able to, because space is actually ASCII 32. Wait. Is it? Well, I cannot remember that much. Well, in this case, we're going to use underscore as our space, in this case. Space. Dot this, question mark, that. What else? So 26 plus 1, and then plus 4, and then plus 10, and then plus another 4, and then plus 2. 47. $48. 16 more. Oh Lord. No, that's 49. 50. 14 more. 13 more. Hmm. 2, 3, 4, 5, 6. 10. 1, 2, 3, 4, 5, 6, 7, 8. 51. Hmm. Oh boy. So far, I have no idea what kind of character I can give at this point. Hmm. Oh, and then another 2. That's in the total 10. 53. Hmm. Okay, let's just have that. Oh, that's 54. Just in case, that is not that is not percentage, that is modulation. That's the added character right there. So far for now we have 54 characters, so 10 more to go. Hmm. Okay, let's take a look at this. So, first thing first is arithmetic. Arithmetic. Still arithmetic. And then relationship. Of the relationship. Wait, these are all binary operators. Huh. Unary or... Then we can have that. That's for sure. And then binary operators. So we can have that. That's for AND. So that's OR. That's AND. NOT is at the front. So 3, 4, 5, 6, and then 10 plus 2 plus 1 plus 1, 2, 3, 4, 5, 6, 7, 8. And then plus 3. 57. 7 more. Hmm. Oh lord, this is going to be an interesting one. How about for sanity's sake, we'll just end up with this. So now that's an extra 4. So that becomes 6. So 3 more to go. Let's see. So there we go. 1. And then 1, 2, 3, 4, 5, 6, 7. And then 10. And then 6 parentheses. 1 unary. 1, 2, 3, 4. 1, 2, 3, 4. 8 binary and 3 relational. Okay, 2 more characters to go. Of course we can add the @ sign and hashtag, but nope. You just need 2 more characters. Fine, what about just small x, small y? Okay, so we have that. Constant char, 128. Wait a second, does not sound good. 20. Oh, and then we have like reason is 128 is because the last character is the null character. Just to say, okay, that's the end of the string. Now, we don't need that. KL, okay. KL and KL, and then KL, KL. And then they do need these things. But we don't need this. And then this is for encryption and decryption. So we have that. So, else if user command enc and it's encryption. Else if user command is dec, then it's decryption. So let's see. There we go. And encryption. Boop. So there we go. And then do that. Okay, I'm going to change it up a little bit. So string user insert, it's going to be that. Now, as long as user insert does not equal to exit, then we will do get line cin into user insert. Whoops. Now, as long as user insert is not exit, or done, then this thing is user insert dot at 0. And then it will just print out everything we need to know. And then kick the rotors, and then more. And technically speaking, if you want to like kick the rotors, not just one place, what you can do is for every amount of snap you want, you just type in a random letter. So yeah, but it's not encouraged to do so because original purpose for the rotor to have that many characters is in order to have like a longer period to make it harder to break the code. And if you have a bigger snap, meaning you're going to have a shorter period and more repetitive. So yeah, we have that. Okay, so this is the encryption part. Wait, L3? Okay, that's a little bit odd now. Okay. K0, P0, R1, R2, R3. And then P0 again. Or how many plug port do we have? Oh, we have 2 plug boards. Okay. So plug port 2. This one over here is plug port 1. Plug port 1 reproduce N2. And then P2 gives us N6. N6. L0. There we go. So that's K0. This is L0. C1. Right there. Alright, so we have that. Now, another one, which is this. And we have decryption over here. go. There we go. Alright, so for now, let's say string user insert is this thing. Now, as long as user insert is not done, we will just say get line cin user insert. So doing the same thing again. Now we can say that C1 is now character 0. So from C1 to N6 to N5, N4, N3, N2, N1. So that one has to be plug port 2. So what we have here is let's flip it around in this case. So let's see out, and then we will type in C1 lamp board and 6 plug board 2. Oh wait, no. And then N5. So plug port 2 gives to N5. Okay. Boop. And then we have router 3. That's N4. And then router 2. And 3. So router 2 did give and does give N3. And then router 1 and 2, and then finally after router 1 is plug board 1. So that's N1. So that's the plug board part. And then back to the keyboard, K0. C0. So C. Yep. End line. So there we go. Then kick the rotors. So that's for decryption. Set site, set site, set site. And then you just want to like print them. Else if user command R4. Wait, when we encrypting it, do we have R4? Let me take a look. Oh boy, we do not have R4. Alright, time to add that thing in. So, okay. So, R4 dot signal left to right. Take N5. Give it to N6. And then N6 becomes N7, and then N7 becomes that. So R3, there we go. R4 becomes N6, and then plug port 1 and 7. There we go, so we have that. Okay, N7. Oh, because we need it right here. N7. Alright, cool. So we have that. Now, the other way around is decryption. Like, for now, let's just say, okay, I'm going to, like, simplify this for now. Like, set it to stone, like the structure. For that's for now. So, becomes N7 and 6 P2 dot signal right to left takes N7. So C1, N7, N7, N6, N6, N5, and so on. Okay, cool. So first thing is N7. And then P2 just becomes N6. P2 becomes N6, so that's R4. R4 gives... Oh wait. There we go. So... R4 gives N5. And so on. Alright, let's do the same thing again. Control C. And then just paste it right here. R4. Set R side. The same thing. Same thing. Set 4. And then R4 print. R4 print content. And then can also take a look at the okay, plugboard. So else if user command is p1 dot print, else if user command p2 and then print. So we'll just do p1 dot print content, p2 dot print content. Just in case the print content. Okay, if I'm correct, print content it just returns that. So Control C, B, B, B. There we go. So that's R1, R2, R3, and R4. Paste it over here, paste it over here. P1 and P2. And nope, P2. There we go. So all the rotors, all the plug boards. Okay. Okay, there we go. Now we can also say P1 set R side. And then, yep. P1, there we go. And do the same thing again as well, but this time it's P2. So this time it's gonna be P2. Okay, so all the prints, all the set sites, some of the rotate, set position, encryption, decryption, and it should be good. Oh, also, we have to set the kick point if possible. Like, okay, let me take a look. If rotor, when we make the rotor, what is the kick point? Kick point is the last one. Oh, okay. Yep, that's what happens by default. Alright. Back to main. Else if user command or command r1.set kick or the ring setting. So R1 kick. Oh, okay. User input cin Control C, Control V, user input, user input. There we go. 3-step process. Control C, 1, 2, and one more. So 2, 3, and 4. So 2, 3, and 4. This should be R2. So it should be something like that. Over here, let's see, print content. Also, we'll just go with \n. That's the new row. We will also need to like say what is the kick point. Kick. Oh wait, to string of this thing. So we have that. So we can see all the things, and then set the side, set the kick, rotate some of them, or set all the positions, encryption, decryption. Yep, let's give this thing a test. So okay, so first thing first, we need to like come up with a router connection list. So let's see if we can come up with that now. Okay, so let's see. "30, 31, and there we go. . and then 32, 3, 4, 35, 36, 37, 38, 39, 40, 41, 42. Oh wait, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, and then 54, 55, 56, 57, 58, 59, 60, 61, and 62, and finally 63. Okay, let's give this a try. Let's see. And then 42, 41, 40. There we go. And then 39, 31, 30, 29. That's 21, 20, 19. That's 11, 10, and then all the way to 0. There we go. So let's see what else. Well, let's see. Eight, 9, and then 10, and then 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20, 21, 22, and then 23, and then 24, 5, 26, and 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, wait, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, and finally 63. So now we can just group them up. There we go. Wait, what? Some of them are missing. Oh. There we go. Two more. Oh. Okay. Prime group. Okay, need to come up with a few more. 0, 1, 2, 3, 4, 5, 6, and 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Now 32 starts from here, and then 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, and then 47, 48, and 49, 50, and then 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, and then 61, 62, and 63. There we go. Comb refers. That's what we have. Alright, and another one. Let's see. One, 2, 3, and 4. Starts with 0. Start with 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 5. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6. 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 9. 1, 2, 3, 4, 5, 7, 8, 9. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. That's 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 15 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh Lord, this is going to be a long one. Let's see if I can. Okay, let me just make a new file. Like, why should not I do this earlier? Main giraffe.cpp. Now, in the main file, I'm just going to have a lot of this. So, int main void. Okay, so let's set up an array. Or okay, I have a better idea. So vector int box. For now it's nothing. Now for int of I is 0, I is smaller than 64, I plus plus box dot push back -1. Now okay, int cur okay, over here. Now while cur is smaller than 64, do the following. If okay, int count. Okay. Int progress. Now is at 0. Current position in the list. Current number working on. Current space jumped. Okay, so we have that. As you can see, every time I'm just jumping spaces, as the whole thing just increases. So if box cur is a -1, then is a -1. Count minus, and then if count is smaller than 0, then box cur is progress. And then move on to the next one. Now what's happened when you like mark it though? So if the current one is a -1, then count is that, then current plus. Move on to the next one. So let's see if we can run a quick simulation. Okay. If cur is bigger or equal to 64, then cur is cur minus 64. Now, when the whole thing is done, wait. Oh, wait, okay. Okay, so we need that. Then when we're done, we just gonna like for this smaller than 64, cout box of I space. So now it just becomes draft main draft. Alright, let's see. what will that give us? Okay, so wait, else, oh, whatever it does, it will always do that. So we don't need that. It's just every time when we came across a negative one, then we just do that. And if we go out of bounds, we'll go back. Okay, there we go. I hope that thing works. Per smaller than 64? No, it should be progress. Now we just need to say just run draft. Oh boy, that's a lot of negative ones. That should not happen. Alright, let's see. You know what? Let's see if I can like pull out let's see if I can pull out psi. Okay, let's see. Alright, so for now, okay, I'm just going to like quickly come up with a flow chart or something and try to simulate what's going on. Alright, so over here we have, alright, cool. So we have our curve, and then we have our count, and then we have our progress. Just in case, what is our progress at the very beginning? Okay, all of them are all 0. Okay. So for now, we're looking at position 0. So it is -1, so fill proc, and then proc plus. Now it's 1. Okay. This will also say cur plus. So if cur plus, then meaning now here. Now this one is also -1. Now once we say cur plus, we say is -1. Yes. Oh, so this should be no. Yes. Okay. Count plus plus. Count plus plus. And then also cur plus plus. Okay. This becomes 2, meaning over here is -1. Yes. Oh wait, before that we need to say if count is proc, no. But if it's a yes, then oh lord, this is a hard thing, but let's take a look at this. So if count is a proc, count and proc is the same thing. Ooh boy, this is hard. Let's try this again. Okay, so here we go. 0, 0, 0. Okay, instead of cur, I'm going to say arrow. So A, C, and P. Okay, there we go. So first thing first, read -1 if yes. Well, for now, definitely just like write. Just write proc. So in this case, it writes 0 because proc is now 0. Okay. And then we want arrow plus. So now it's over here. And then arrow plus. Okay. -1. Yes, it is. And then, oh wait. I forgot that. So we'll move on to the next one. And then if it is -1, then WP right proc, and then proc plus, and then move on to the next one. It's -1. Count is proc. Count is proc. If yes, then continue. However, if no, then count plus A plus. So now over here it's -1. Is C and P the same? No. Oh wait, it should be P -1 in this case. So in this case, P equals 1. Nope. So C plus, move to the next one. Oh. And then A plus. And go on. Go. Is it -1? Yes. And then if C is proc -1, yes. Right proc plus. Arrow plus. Oh, every time pro us. Okay. Count 0. And then A plus whatever. Read -1. Let's say it is -1. Is P that thing? No. Okay. Oh, what will happen if I stumble upon a number that is not -1? So if no, then move on to the next one. Okay, so at least now we have a flowchart to follow. Let's see if I can convert this into code. Alright, let's get back to this. Alright, let's take a look at this. Okay, so if box cur is -1, if so, check if count is progress -1. If so, box cur is progress, and then progress increment, and then count set to 0, and then cur move on to the next one, and then go back to check if it's -1. So basically that's done, that's done, that's done. Okay, so if C is not p-1, meaning else down here, count plus cur plus, move on to the next one, and then go back just to check if it's like read is -1, and then if it's not -1, then basically just say cur plus. Now every time when we say cur plus, okay, what we meant is cur is cur +1, but take the whole thing mod 64. So replace that, replace that. So let's see how does it runs. Well, it has nothing. Huh. Hmm. Oh Lord. This is hard. Okay. Let's see. Let's see. There we go. Proc stocks at 0. Huh. Proc stock at 0. So so maybe count should have start from -1 instead. Alright, there we go. That's an interesting one. Let's see. Maybe this is the thing that we want. Uh-oh. Did I just delete that thing? Okay, so 0, 1, skip, 2, skip, skip, 3, skip, 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 4, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Okay, so it somehow works. So it works. Now, let's just say just want that. Let's see. So boop. Boop. So there we go. Now we have that. Let's just copy and paste this whole thing. Alright, let's get back to this. Space jump. Alright. That is some brain exercise we have there. Space jump. Okay. Oh. That definitely messes my brain a little bit. Okay. Just one more. Just one more, then we can uh test this like Enigma thing. Hmm. Let's see. Uh hmm. Hit save for this one, and then hit save for rotor. Comb reverse prime group, comb reverse space jump. Hmm. What kind of... Alright, you know what? Since way beforehand, I have made the online version of it. So, let's take a look. Alright, let's take a look at what I have created before. Like way earlier. Like when I say way earlier, I meant by somewhere around like several months ago. So let's take a look at this. So if we take a look at our team's website, this is where I'm at right now. Over here, we'll go to like learn over here. Oh boy, it's still loading. Ah, there we go. All right. Aha, there we go. So over here we have 64 key Enigma 3. That's what I meant. So over here we have this. Yep. I made it beforehand. However, it's slightly not exactly that user-friendly, but usable. Now, rotor 1 right side. Okay, so sequence 0 apply to rotor. So it's just simple. Okay, so sequence all 0 is just like simple from 0 all the way. So it's like its identity. What about 1? Apply to rotor. Starting from 1, 64. Huh. Okay. Cross. What's that? 1, 2, 2, 3, 1, 2, 3. Oh, so this is space jump. Well, space jump in a way. How about that? Okay, I'm not quite sure how I came up with these. Huh. Okay. Yep. So we have this. This is what we have before. However, the way you use it is when you click on it, it just shows up right here. But the problem is you just have to like find the character and then click it. So it's a little bit slow. So yeah, that's the only thing that we have to like worried about. Now with this thing going on, what you can do is just like you have a stream of characters, and then you can just like go ahead and start encrypting or decrypting or whatsoever. Alright, so hmm. Alright, I'm going to try this. So I'm gonna go with 0 to, oh wait. Okay, let's see if I can write code for that. So same 64. Okay, so hmm. For int I starting from 0, as long as I is smaller than 32, I plus plus. For now, I'm just gonna fill up half of them. So box of I is I multiplied by 2. And then for int of I starting from 32, I smaller than 64, I plus plus. Okay, so I know when its position is 63, then it should write 1. And then position 62, then we should write 3. So let's just look at the pattern over here, like 61, then write 5. Well, one way to do it is we start from I is 63, and then we will make sure that I is bigger than 31. Then every time we do it, I minus minus. So position 63. If I just say 64 minus position, then this will be 1, this will be 2, this will be 3. So, and then multiply by 2. And then minus 1. So position 60. 64 minus position, that's 4. Multiply by 2. And then minus 1. So that works. Alright. So 64 minus I, that's what we have. Take the whole thing, multiply by 2, and then minus 1. So this is what box of I should equal to. So if we run the whole thing, oh wait, I forgot that. Let me, there we go. Okay, cool. So now if we run the whole stuff, we should be able to have this. And then Control C, Control V. There we go. Jump hill. Alright, there we go. Save it. Finally, 6 of them. The first easiest should be just reverse. And then we have hill jump. And then we have comb and comb reverse. And then prime group and space jump. There we go. So we have these. Of course, you can like come up with your own arrangement in this case. Alright, let's see. Let's compile the real thing. Okay, so first thing first, clear. Just run. Oop. So basically saying now we are waiting for user to enter the command, but let's just say right now I type exit. There we go. Done. So oh wait, let me type exit again. So if I go to main CPP, help. There we go. So first we have R1 print. And then R2 dot print. And then R3 dot print. And then R4 print. Or we can just say rotor X print. X is 1 to 4. So print, we can also set side, set R side, and then we can also set kick. Kick. Set R side. Oh, okay. B. Now it's just 1 to 2. Go print. Can also print the logboard as well. So, and then for rotors, we can set side or set kick. And then for plugboards, we can only set the side only. Now for rotors, rotate. Three to 4 or A. Oh wait, I almost forgot. We can also oh, come on. I just want to open this thing up. There we go. Go rotate. Four and 4. There we go. Oh Lord. Okay, sometimes Microsoft Visual Studio Code just becomes messy. Okay, so if that's the case, this also means that we also need R for pause. So R4, R4. And then R4 pause, R4 pause. There we go. So we have that. RA set pause. Oh, okay. RA set pause. And then enct or deck. Enc. Deck. Let's see. See out. NDL. All right. Let's see, will this thing works? Compile. And then just clear. And just run. So for now, let's just gonna type help. So those are the available commands that we have. So for now, let's just gonna say R1 dot print. For now, it's just going to be these things. So let's set them up real quick. Boop. Okay, so R1 dot set R site. Insert content. So let's see. Okay, I'm going to do it this way. Plugboard, rotor 1, rotor 2, rotor 3, rotor 4, plugboard. So I'm setting rotor 1, so I'm just going to copy this thing, which is hill jump. Control C, Control V, separation character. Okay, so let's do R1 dot print again. So yep, as we can see, it has been set it correctly. So if we were to do the same stuff again, so R2 dot set R side. Now we insert the content. Control V, separation character, and then R3 dot set R side. We will just copy this whole thing, comb reverse, C, Control V, separation, and then we just go R4 dot set R side, and then we just gonna copy, paste, and there we go. So if we say R1 dot print, that's what we have. And then if we do R2 dot print, this is what we have. And then we can say R3. Oh, okay. And then we can say R3 dot print. This is what we have. And we can have R4 dot print, and we can see it's good. Now we just need to like make sure let's see, now we just want p1 dot print. For now, it's exactly the same, untouched, like identical. So in this case, I'm going to say p1 dot set R side. So insert the content. We can just like copy this whole stuff, and then paste it right here. Basically, it's just reverse the whole thing, and then comma, and then let's copy this thing, space jump, Control C. So over here we have like two plug boards over here. So P2 dot set R side, paste it right here, comma, boom. So P1 dot print. Yep. And then we can have P2 dot print, and we have that. And then so the Enigma machine, or the 64KE Enigma machine, is now ready. So we can run the simulation. So let's say, okay, let's type in help. Okay, RA set pause. So RA dot set pause. So for example, we're just gonna go. I don't know. Okay, let's see what our calculators say. Let me pull out pi. So it's somewhere around 3.1415 something. So I might go 31, 41, and then 59, and 26. Alright, cool. So if we take a look at P1 print, over there we can see okay. Okay, that's unexpected. Oh wait, that's P1, not R1. Okay. R1 print. So over here, R1 over here has been like pushed until 31 or something. And then so R2 dot print push to number 41. And then if we do R3 dot print, got to 59, pretty good. And then R4 dot print, that's, there we go, 26, perfect. Okay, now we can start encryption. What should we encrypt? Okay, let's try to encrypt hello from VRChat. ENC. Boop. So, caps locks. H E L O. Terminated. Called after throwing an instance out of range. Huh. Interesting. Usually that do not happen. Out of range. 64, 64, 64, 64, 64. Hmm. One, two, three, four, 5, 6, 7, 8, 9, 10. That's 26. That is also 64. Okay, that's... Okay. Good, so at least now we know thing is off. Alright, let's take a look at key lamp. Let's see if we can like print them. Oh yes, we can print the content. And then we can say oh wait, caps lock. Okay. So we can say to string I So we can do the same stuff over here. Bring this thing, that thing. There we go. Should be good. Alright, let's make a new command. This case. There we go. See out. K0 dot print. So else if user command is K0 dot print, then KL dot print content cout. KL print. Let's quickly give that a check. Alright, there we go, and then we'll just say just run whatever. Yes. Okay, so for now I'm gonna type in help, and then I'm gonna just go KL dot print. That oh, it's K0 print. Okay, KL print. There we go. Choo. Then run. So KL dot print. So let's see. That's okay. So you print the ASCII of it. That's not exactly what I'm asking for. However, it does ranges from 0 to 63. Out of range. E and C. H. E. Okay, let's try that again. E and C. E, E. Okay, let's try that again. E and C, E, U. So every time the second one just goes out of range. So, okay, I'm going to do some brute force debugging. Hmm. Uh. There we go. Go. Here we go. So that's 1, that's 2, that's 3, that's 4, 5, 6, 7, and 8. 9. So, debug. Just run E and C, H, and then E. So not even a single flag. Okay, I'm going to try remove that see and ignore stuff right there. So go, just run E and C, H, we have that, E, oh, ah. Okay, I see. Okay, turns out we do not need see and ignore. So let me remove the flags. Yep, because I forgot it. Now we just use get line. There we go. Alright, there we go. So, okay. One thing for sure, it did not kick the rotors. Oh wait, I do need to kick rotor number 4. Okay, I see. Okay, so need a bool. Need kick. R4 dot rotate for 1. If need kick 3 is true, then bool need kick 2 is R3 dot rotate for 1. If need kick 2, then bool need kick 1 is R2 dot rotate 1. If need kick 1, then R1 dot rotate for 1. So in this case, let's just remove that. Okay, so it's the same thing for deck, and we don't need see and ignore, and then we're just gonna replace it. Okay, I'm going to type done and then type exit. Recompile. Oh yeah, the reason it did not encrypt is because all the routers are identical. That's why. Okay. Just run. So for now, I'm going to say R1 dot set R side paste it over here, comma, and then second one, Control C. So R2 dot set R side. Whoops, paste that thing in. Oh lord, that did take a while to get in there. Okay, R3 dot set R side. So number 3. Boop. Comma right there. Alrighty then. R4 dot set R side. And then just and paste the whole stuff. Then comma it out. Alright, 1, 2, 3, 4. So let's take a look at that. R1 dot print. Yep, we have that. R2 dot print. Okay, cool. R3 dot print. Okay, R4 dot print. We also have that. Alright, cool. So P1 dot set R side. So for P1, let's go with that. Paste it over here, comma it out. P2 dot set R side. Control C, Control V, comma it out. Alright, so P1 dot print. Okay, and then we have P2 dot print, and then we have that. Alright, and then let's see if we can encrypt stuff. 1, 2, 3, 4, 5, 6, 7, 8. E N C. Oh wait, no, not yet. Okay, RA dot set pause. 31 3.1 41 5926. Alright, so 1, 2, 3, 4. R1 dot print. Yep. R2 dot print. Wait a second. What is R2 dot print? Print content. What about set pause? Hmm. Let's try that again. RA dot set pause 41 59 26 P2 dot print. Wait, oh, P2 dot print. Okay, R2 dot print. There we go. R3 dot print. R4 dot print. Yep, that looks pretty good. Okay, P1 dot print. That's plug port 1. And then P2 dot print. Plug port 2. Alright. 1, 2, 3, 4, 5, 6, 7, 8. ENC. Encryption starts. Caps locks. H E L L O underscore F R O M underscore V R C H A T, and then done. So this is the string we have. Alright, so now let's try to decrypt this. Now the rotor position is out of sync. So in this case, let's do RA dot set pause. Let's crank it back to 31, 41, 59, 26. Now let's try decrypt. Now the first thing first is B minus star W. Okay. B minus star W. B minus star W dot B colon G dot B colon G dot B colon G dot write XP dot write XP up 1 equal IB. Up 1 equal IB. So over here we just decrypted from, and then we just got HELLO underscore FROM underscore VRCHAT. So there we go. Encryption and decryption. Oh my lord, this feels good. Now we just have to make things a little bit prettier and user-friendly in this case. So, first thing first, definitely, we have to like shorten the commands. So in this case, let's just go with done, and then let's go with exit. So first thing first, definitely the command. So KL Hmm. Okay, print is just P. Set R site is just S. Oh wait, set R. Okay, because we also need to say set kick. Set R. Rotate. Set pause. SP. Hmm. Set R. R. Now this one is set K. Set R. Set R. Rotate. It's just R. Set pause. Set P. There we go. Um. Content of the keyboard or the lamp board. Print the content of the rotor. Print the content of the plug board. There we go. Set the wiring of the rotor. Set the ring setting of the rotor. Upward. Oh, okay. Set the connection of the blockboard. Rotate a rotor. Set the position of the rotors. Start encryption. And of course, start decryption. and of course cout exit close 60 oval 64 KE Enigma CPP. There we go. DL. Alright. Now, one quick question though. Let me take a look. How do I clear the screen of the console? Hmm. Okay, let's see. Hmm. Alright, let's take a look at this. So, cout ENDL cout clear the screen. So let's take a look. Else if user command clear, do the following. Wait, what? Oh. There we go. And then I'll just go boom. Okay, there we go. There we go. Alright. If def when 32 elif defined Linux and if. So so if it's Windows, then we can do, wait, are we like using namespace std? Okay, let's do that. Using namespace std. Okay, so we can just do system, and then we'll just go with uh CLS, and then for Linux it's gonna be system clear, or let's see, so elif defined Apple and defined Mac, also do system clear. Of course we know that this won't happen in this case, so yep, it's safe. Alright, let's take a look at this. Okay. Let's go with load 0. For now, we'll call it load 0. Okay, so loading a preset. Loading preset 0. So else if user command is load 0, then do the following. First thing first, okay, so it's definitely r1 dot set r side, and then the blob, and then the character. So it's definitely this. Hill. There we go. And then r2 dot set r side. This one, for example, it's comb. R3 dot set r side. Oh, capital S. There we go. 3, it should be that. Huh. Wait, maybe I have a better idea. How about I'll just print out everything? So just C out. LD64. There we go. And then we'll just go just copy and paste. Block. There we go. It's a huge one, yes. NDL, there we go. Do the same thing over here. There we go. So we have that. Boop. And we go. We go. Alright, that looks pretty good. So technically speaking, we don't need this thing down here. Alright. One thing for sure, I definitely need IO magnet on this. So okay. Set fill. And then align to right hand side. Set with let's say 2. Huh. Is it something like this? Or alright, let me quickly check. What is the correct syntax to use IO manip set with set W. Okay. And IO manip. Whoops. How to clear all the flags. Oh Lord. Oh boy. Okay. Let's try this. Set width back to a single character. Set fill to a space character. So yep, we definitely need that. This one is for encryption, and for decryption, we also need this as well. So paste, and then finally over here, set width 1, set fill, spacebar. Okay, cool. So we can just say clear. Get that whole thing. There we go. And then now we can just run this stuff. Say help. And then we have those. First thing first, let's see if we can clear. Yes, we can. Alright, cool. Let's type help again. This, I know it's stupid, but yeah, whatever. So in this case, let's just go LD64. Okay, that did not work. What was it? Oh, okay, that's why. Okay. Boop. Recompile. There we go. Now we'll just run the whole thing. Now before that, let me zoom in so you guys can see better in this case. First thing first, clear. Okay, now let's go with r1.print. So we have that. r2.print. Okay, so we have those. Let's hit clear. Okay, Now let's go LD64. So those are some of the stuff we can have. Alright, so let's go with R1 set. Oh, R1 set right hand side. So first thing first, we can just copy and paste some of the stuff over here. R2 dot set right hand side. Jump hill, let's go with comb. And then R3 dot set right hand side. Comb, after that is comb reverse. And then R4 dot set right. That is prime group. And then we can say P1 dot set right. Verse paste. And then so separation camera. And then finally P2 dot set right. There we go. Now we just need to say clear, and then we will just go okay, P1 dot print. Okay, kick is missing. Oh wait, that is plugboard. Plugboard has no. Yep. All right, let's go with R1 dot print. And then we have R2 dot print, and then we have R3 dot print, and then we have R4 dot print, and then we have P2 dot print. Alright, let's go clear. Now let's go help again, just to see what is set. RA.SP, okay. Rotor, all set position. Pause 1. Shall we choose a different starting position in this case? Because we've been using like 31, 41, and then 59, 26. Alright, time to pick another number. In this case, E. So, 27, 18, 28, and then another 18 again. Clear. So if we do those R1 prints again, yep, R2 print, R3 print, and then R4 print. Yep, you can see it's really different over here. So we just go clear. Alright. Now we can try to encrypt another message. Alright, you know what? I'ma just like encrypt the name Relativity Express, which is where I'm at right now in the background, if you can see. Okay, so ENC. Boop. Caps locks. R A. Okay, seems like Ion Man didn't kick in. A B E. Relativity. And then Relativity Express. Done. Okay, let's try encrypt again. But this time I'm going to be naughty. Ah, of course. Okay, so it will always like take the first character of it. Alright, cool, good. We're in good shape. So AX BX left right. AX BX left right. F9 O/QB. F9 0/QB. Wait, that's Q8. Y question mark and R2 left underscore. For now, that's gonna mean completely nothing at all. Now we're just gonna type done. So that message down there, that's what we have. So let me type deck. We know it's time to decrypt now. Oh wait, I forgot one thing. RA.set pose. So 27 18 28 18. Okay, so now I'll just go deck. First thing first, caps lock. A X B X AX BX left right F9 0/ Q8Y question mark. Q8Y question mark. R2 left dash. R2 left underscore. So over here we have Relativity Express. There we go. So we have that. Alright, cool. Now I'll just press done at this point. And then I can say clear. But I can say RA dot set pause. For now, I'ma just go like all just 0. So I can say r1 dot print at 0 s. Okay, r2 print also 0. Okay, I'ma just start encrypting now. I don't know will it kick the next rotor, so let's take a look. Caps lock. Now, problem is, if I keep on doing A, up there we go. A can sometime be encrypted as A. Perfect. Now, just want to make sure, will it kick? Whoa! 4 characters in a row. Very unlikely, but that's what we have. Okay, for now, I'ma just say done. Done. There we go. Now, r1 dot print. Okay, r2 dot print. It does not even kick? Oh, wait. I should check R4. R4 dot print. There we go. Okay. R3 dot print. Yep, it got kicked a few. Yep. Okay. So, now I'ma just go exit. There we go. So yeah, Enigma machine, 64 key Enigma machine. Alright, cool. So, alright. C? No, just C. C. There we go. Start encryption. Characters. Start decryption. Characters. And of course, you've guessed it. I want the entire string. So, CS. The CS. String. String. There we go. When done, type done. Backslash, backslash. When done, type backslash, backslash. Oh wait, get that thing right. Done. Alright, cool. So we have that. So dot 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 dot. Alright, so enc dot c dot c. Okay, so let's see how can we like make s in this case. Well, in this case, because a single string is finite, so we can actually just simply use a for loop. Hey! Okay, that seems easy. So user command enc s there we go. So for int I starting from 0. Okay, let's say string, and then we're just gonna say user input is equal to that, and then we can say get line sin. Wait, let me see out. Insert plain text. So cin and then user input. And then for loop I smaller than user input dot length I plus plus. Do this for every character. We just need that, and then just decrypt it, kick the rotor whatsoever. Boop. So C0 is the user insert at, in this case it's the user input at I, and then do everything. And then kick the rotors whatsoever. Over here we have set fill, and right. Okay, let me check this thing. And I minute how to align right hand side. Oh. Set W. Huh. Well, seems like I have typed everything what I can. or okay, let's also make a string. Output string. For now, it should be that. Now, every time when we are done with the thing, output string is output string plus the final outcome, which is C0. No, C1. Uh-oh. Okay. For string car. Alright, because I remember there is a function I made in order to turn a character into a string. Did I spell it with a capital S? Well, at this point, it doesn't matter. Okay. Let me quickly ask. How to convert a character into a string? There we go. Alright, seems like not exactly a really good idea. Can we do pushback? Oh, yes, we can. Alright, we'll just do C1 then. And then when we are done with the for loop, we can say output string. Or maybe we can just say ciphertext. Output ciphertext. Output string. Okay, so we have that. So it's almost the same thing over here. Almost the same thing. Now the only difference is it's decryption. So I'm gonna just paste it over here. Now let me collapse this thing. Okay, so over here we have it. We just need this part. There we go. Paste it over here. In this case, C0 is what we need. So, oh wait, let me get this thing. There we go. C0. So, insert ciphertext. User input. User input. And then all the way down. Finally gets C0 back. And whatever. So output plain text. There we go. So okay. I guess something's burning. What the hell? Alright, so let's see if this thing works. Boop. Oh, yep. Okay, so let's see. Compile. There we go. And then now we'll just clear. There we go. Okay, so let's run this whole thing. Boop. Okay, so we'll just type in help. And then there we go. We have that. So encryption string. Oh, wait. Load 64. And then R1 set right, which is this thing. And then R2 set right. So jump hill. And we have comb. And then R3 dot set right. And then R4 dot set right. Alright, and then P1 dot set right, which is actually just reverse the whole thing. And then that thing, and then P2 dot set right is space jump. Like, okay, also here's one thing I would like to also mention. On the Enigma machine, on the plug board, you can only make pairs, but you cannot make cycles. However, on this 64 key Enigma machine, you are allowed to make cycles on a plug board, on the plug board. Yep, so we have that. Now, let's just go clear. Now let's just do R1.p, and then we have R2.p, R3.p, and R4.p. And then we have P1.p, and then we have P2.p. meaning just to print all the content out. Now in this case, let's just go ra.setPos. So position 1, let's go with, let's go with my favorite number. Like 1, 2, 4, 8. So 1, 2, 4, 8. Perfect, there we go. Now let's just go clear. Now I'm just gonna do enc dot string. So plain text, hello from Relativity Express. So boom, here we have the ciphertext down here, quick as lightning. Now, moment of truth. Let's go set RA, set position. So 1, 2, 4, 8 again. Now let's go dect dot string. Did we not set that thing up? Yep, we did not set that thing up. Oh god damn it. There we go. Save. This means we have to run the whole thing again. Oh lord. Alright, let's go exit. Run the whole thing again. Or compile the whole thing again. And then we'll just run it. First thing first, LD64. That gives us everything. Or you know what? Let me make things easier. I'm just going to have ENDL. Like just double ENDL. Okay, there we go. Okay, let's run it. Boop. First thing first, let's clear it. And then let's go LD64. Boop. Those are the stuff. Alright, R1 dot. Okay, you know what? Let's go with P1 first. Set right. And then R1 dot set right. And then R2 dot set right. Paste it right here. And then R3 dot set right. Which is this. R4 dot set right. And then finally P2 dot set right. Now we can go clear, and we can do RA dot set pause 1 2 4 8. Now we can go clear again, and then we can do ENC dot S. Now we can do hello from relativity express. So, yep, here we have the same plain text again. So if I go DEC.S. Oh wait a second. Alright, I'ma just do that. Okay, let me go RA dot pause or set pause 1 2 4 8. There we go. Now we can do DEC or deck and then S, and then we will just simply put this thing in. Okay, that does not work well. Alright. Let's take a look at that. Deck string. I is 0. I starting from this I plus plus. That's why. Okay. That's why. Okay. Exit. And let's see. Oh, it's ready now. Alright, let's do this. So, LD64. So we have that. R1. No. Let's do P1 dot SP. No. Set R. And then just put everything in here. And we can do R1 dot set R. In this case, we will use jump hill. So copy that thing, paste it over here, and then over here we can do R2 dot set R. Jump hill. The next one is comb or comb. Many ways to pronounce that thing. There we go. And then R3 dot set R. Reverse comb or comb reverse. I don't know. Boop, and then boop, and then R4 dot set R. In this case, it's gonna be prime group. Control C, paste it over here. There we go, and then let's finally have P2 dot set R. Control C, Control V. There we go. Now let's just clear this thing. Okay, now let's see. Alright, let's do enc dot s, and then we can just say hello from relativity. Oh wait. Relativity express, and then boom, we have those. Oh, this looks very different. The ciphertext looks very different. Oh wait. Oh wait, I think I know why, because I forgot to set the position, of course. Okay. So let me quickly do that. So RA dot set position 1, 2, 4, 8. And then let me do enc dot s again. Let's see if I can just simply copy and paste the whole thing. Control C, Control V, boop. There we go. Now that's the whole thing. And then we can go. Okay, so that's our ciphertext down there. And then we can go RA set position again, just to rotate the rotors back to the initial position in this case. So 1, 2, 4, 8. Now we just gonna dep string. So here we go with our ciphertext. Boom. And there we go. That's our plain text. Hello from Relativity Express. Ah, finally. Okay, cool. So yeah, this is 64 key Enigma machine. Oh boy, finally done. How long I've been streaming? 9 hours, 32 minutes. Cool. Alright, so I'm going to upload this onto our website or onto our GitHub. So yeah. Afterwards, you can download it and then use it for your own or whatsoever. But yeah. Maybe I can also like ask ChatGPT how to like run C++ stuff online. We'll see. Now let's do a small experiment. So let's go RA dot set position. Okay, that's pretty odd. Okay, RA dot set position all 0. Now if I just type enc dot s, so I'm just gonna say today we have been streaming on Twitch, on VR chat, just to make a weirder version of the Enigma machine. And then, of course, instead of just 26 keys, this time we have 64 keys. And we added another rotor and another plug board. Alright, so this is what we have. Boom. And yep, this whole thing encrypted. This huge thing. Now, if I go DEC, no, wait, before that, let's go RA, set position all 0, and then we go DEC.S, and then we'll just feed in these stuff. There we go. And then we'll just go plot. There we go. Today you have been streaming on Twitch on VRChat just to make a weirder version of the Enigma machine. Instead of just 26 keys, this time we have 64 keys, and we added another rotor and another plug board. So yeah, it's extremely long. So in this case, let's just go r4.print. Yep, it ended itself on position 16. What about r3.print? Oh, okay, so it ended up at position 3. So let's do a quick calculation. Clear. Okay, so 3 multiplied, no, wait, 0 to 1, 0 to 2, no, 0 to 1, 1 to 2, 2 to 3. Ooh, okay, so yeah, it's 3. So 3 multiplied by 64, and then plus 16. Okay, so we have 208 characters up here. So yeah, there we go, it's working, yay! Of course, maybe this will be used as a lore tool, because maybe afterwards I will hide Easter eggs or code or whatsoever by using this thing. But of course, I will have to like scatter the key or whatsoever it is. But yeah, cool, nice. Oh boy. There we go. Okay. So yeah. Okay, there we go. And VR chat lagging again. Let's see how long this time VR chat will come back to life. There we go. Alright, cool. So, yep. There we go. That's the entire stream for now. So, yep. I will upload this whole thing onto our GitHub and our website. So, if you want to take a look at for yourself, feel free to download it, and it's going to be free and open source in this case. So, yeah, if you watch this stream to the very end, thanks for watching. And then when I will stream again, I have no clue. So, yep. If you like what you're seeing, drop us a follow or join our Discord or whatsoever. Alright, and then I'll see you guys next time. Bye. Wait, let me do this classic one. Bye.